Alright guys, hello and good morning. What's up? Am I audible? If yes, quickly let me know on the chat. So this time for CAT 2024 slot 3, right? So we have discussed CAT 2024 slot 1, slot 2 and even slot 3, the easier questions, right? I hope you have seen all these videos, and today we are going to talk about slot 3 difficult question since it was the final one. So I thought to come live, right? Of course, we are going to see those 11 difficult questions that came in CAT 2024 slot 3. Alright. Can you tell me the difference between CAT 2023 and CAT 2024? Why was CAT 2024 termed easier than CAT 2023? Although CAT 2024 also had some very difficult questions, very new questions. Then since still, why the cutoff had a difference, or why people called that CAT 2023 was difficult? Why? Because the idea was, when we talk about CAT 2023, then the doable questions were around 7 to 8. But the doable questions also needed some time. Yes. Whereas in CAT 2024, the doable questions were quite easy. If you have seen the videos, those questions which were doable were fairly easier. So CAT is a selective examination. So if a person who is a good, good in selecting, a person who is good in selecting the right questions could actually score better in 2024, right? So that was one of the major difference. See, today we are going to do the 11 difficult questions and you will see that they were tough, right? Now the idea is, guys, how we are going to do these 11 questions. So let's everybody assume that we have hunted the first 11 easy questions and we are able to do 7 questions, right? And now we are jumping to the round 2, correct? So that we get the feel of the exam. Now you are just left, imagine a scenario, you are left with 10 to 15 minutes and we are down to round 2, okay? And now we know that we have already done the questions which we have seen earlier. These are going to be either new scenarios or long questions. So you will have to decide. Okay? You will have to decide whether to attempt it or not. So first we'll make the decision and then of course we are going to do all 11. But you will have to decide with me so that we get the idea, right? Alright? So that we get the idea whether we have to attempt that particular question in the round 2 or not. Alright, so are you guys ready? Are you guys ready? So I'll just show the question and I'll give you 20 seconds where you will decide whether you would have done this one or not. Okay. So first, starting with the arithmetic questions, not the difficult one or maybe the difficult one, I don't know. Take 30 seconds and decide whether you would have done this or not. We eventually will do it anyway, but I just want to see your judgment. Imagine 15 minutes are left, so you don't want to spend any more minutes solving a wrong question. Thank you so much, guys. Thank you for so much love and all the support you have been giving me throughout this channel as well. Means a lot. Doable? Second round, right? Doable in the second round? Absolutely yes. First round is already over, right? First round is over. We have done those 11 questions. The video is already out there. We are talking about the second round only. We are in a scenario, 12 minutes are left. We just have the time to do 2 or 3 more questions, right? Easy one, right? We can do it. Doable? Yes. This should have been in the second round. Why? This is an easy algebra, average question. The only difficult part here is that it is little long to read. But if we read it slowly, we can do it. So just attempt it, everybody. Doable for the second round. Absolutely, yes, you guys are correct. Spot on. Try it. Try. I'll show you some crazy methods, right, for algebra questions. Something new will definitely be there. Average question, language, little long, but still doable. Spot on. Absolutely nice. You're judging the questions well now. Average of 3 distinct real numbers is 28. Let's call them A, B, and C. If the average is 28, what is the equation, guys? What is the equation? 28 into 3, that's 84, right? So one equation we already have, that a plus b plus c is 84, right? And we are done till here. Now next, if the smallest number is increased by 7, this guy becomes a plus 7, and the largest number reduced by 10, so this becomes c minus 10. The order of the numbers remains unchanged. Fantastic. Still they are in increasing order. The new arithmetic mean becomes 2 more than the middle number. What will be the new arithmetic mean? Can you tell me? Direct, without calculating much. What will be the new arithmetic mean? What has happened to the sum of the numbers? This remained same. This increased by 7. This decreased by 10. So net, we have decreased by 3, isn't it? So see, I'm telling you how to save time, right? How do the things work in our mind? Net, we have decreased 3, correct? So if we have decreased 3, then how much is the average decreased? 3 upon 3. Value decreased upon number of numbers. So 3 by 3, that is 1. So average has been decreased by 1. So if average is decreased by 1, so now it is 27. Are you able to do these things in mind? So new average is 27, correct? So once you say me that the new average is 27, I'll write it here. All right, so new average. And you're also telling me that new arithmetic mean becomes 2 more than the middle number. So this guy is 25. So that average is 2 more than the middle number. B has to be 25. We are sorted. Yes or no? That much you write in the paper, right? That much you write in the paper. Because in the CAT paper, you're not there to scribble it out. You are there to observe, right? We have B as 25. Put B here 25. We already have A plus C as 84 minus 25. 84 minus 30. 54, right? And we are here to subtract how much? B was 25. Right? Accordingly, subtract. Perfect. So 84 minus 24 is 60. Minus 1, that is 59. Fantastic. We already have A plus C. What's next? It says, while the difference between the largest and the smallest number becomes 64. So this minus this is 64. This minus this, we have C minus A. Now look at the constants, minus 10, minus 7, minus 17. This is equals to 64. That means C minus A is 81. C plus A is 59. Two equations, two unknown. What they are asking us? Largest number. What is the largest number? We'll add and divide by 2. Yes, 80, 50, 130, 140 by 2, 70 is the answer. Now have a look, how much have we written? This is what we have to write down there, right? Understood how you can increase the number of attempts in these last days? So this was fairly easy one, doable, right? Just for the round 2, because scenario was not something a standard pattern. We have to read it, we have to understand what you are telling us, we have to form the equations. That is why I kept for the round 2. Round 1, only those questions which we have seen, right? Which we have already seen. Perfect. Shall we go to the next one? All right. Time for you to decide whether this was supposed to be done in the round 2 or to be left in the round 2. Akshay, it is maximum from my end, beta. You have to increase from your end. I guess there is no problem in the sound. All right. So guys, you can try. I am explaining Shivam. Shivam, see what happened was, we had 3 numbers, right? And the average was 28. Now this guy was increased by 10. This guy was decreased by 7, or it was something opposite, I guess. This was increased by 7 and this was decreased by 10. So what we have is net decrement of 3 plus 7 minus 10. If you divide it by the total number of numbers, so the average will decrease by minus 1. So change in average can be we can find out the change in average by change in the sum divided by the number of numbers. So change in average is change in the sum upon number of numbers. Change in the sum is minus 3, number of numbers is 3, change in the average is minus 1. So new average 27. That's how we did it. What about guys this one? This one, doable. Try then. this had a serious calculation, right? If you don't figure out the right way. If you observe something in the calculation, this becomes easy. Not easy, but that think or that thought or that thinking at the end is little difficult, right? Specifically when it is a theta question, there are no options, right? If it would have been a theta, if it would have been a non-theta question, it was very easy. I would have started plugging in the number at the end of the equation. But why here it becomes difficult? Because at the end you will see that we come to a very difficult quadratic. Let's have a look. Are you guys ready? Let's have a look. Shall we try it? The concept used is easy, normal removal replacement. But what is difficult is the calculation part, right? It should have been, kept for later, not a round two question, believe me, right? Because there is, a variable I will have to assume. And as soon as variable comes into the picture, things become difficult, and then it is moreover a theta question. I don't know that if I end up in a difficult equation, I don't have the options to go back, right? Let's try. So a certain amount of water was poured into 300-liter container and the remaining portion of the container was filled with milk. So let's assume that this is a 300-liter container. You pour water as x liter, so milk becomes 300 minus x liter. That is the scenario. Yes. Amount of solution was taken out, which was twice the volume of water. So you took out 2x, right? And water was poured into refill the container again, and you poured water 2x. Scenario is in front of us. Simple removal replacement question, right? X liter water, 300 minus x milk. 2x liter taken out, water poured in 2x liter. At the end of the day, we have 72% milk. 72% milk means how much? 72% of 300. That is the final milk. 20% is taken away. We have 216 final milk, right? So we know the initial volume of the milk. We know the multiplying factor. And then we know the final volume, right? Correct. So scenario is clear to everybody. We have poured some water, so x liter. Remaining is milk, so 300 minus x is milk. We are taking out 2x liter of the solution, replacing it with 2x liter of water. Finally, we have 72% of milk, that is 216, yes. So, guys, initial volume of milk, of course, we are going to follow milk. Why? Because milk goes out but never comes in. And in removal replacement, we follow on the quantity that goes out but never comes in. So, initially the milk is 300 minus x. Multiply by the leftover factor is equals to final milk. Tell me what is the leftover factor? Leftover factor is leftover volume upon total volume. Total volume we know 300. What is leftover volume? When you are taking out 2x of 300, what will be the leftover volume? 300 minus 2x. So leftover factor becomes leftover volume at the time of removal upon the total volume. So we have a quadratic equation within 15 seconds. We can do it, but it requires some calculation. Yes or no? Everybody, right? Yes, some of you might be doing it by 1 minus 2x by 300. Then you take the LCM, you will reach here only. Yes. So if you're using 1 minus V out upon V total, that is also correct. You will end up here only. So I do that part in the mind itself. Calculate the volume remaining, right? Now, how to handle this calculation? What do you observe? What I observe is this is 6 cube. This is 6 cube, right? Which is nothing but 2 cube and 3 cube. Let's factorize and play. This is 300. So that means 1, 3 and 100. Now guys, imagine, watch carefully. This guy has 100. What can you tell me about x? Think. That is what CAT is all about. Approaches. Think very carefully. Can x be a random number like 4 or 5? 3, 7, can it be a number? Think, if I put x as 7, this will end up at 293. This will end up at 300 minus 14. You won't have even a single zero. I need two zeros. The right hand side has two zeros. That means this quantity should have one zero. This quantity should have one zero. Think, x has to be a multiple of 10. If it is a number like 10, then only we have 290 into 280. We will have two zeros. Getting the point? And don't say, sir, why not one person can have two zeros? Suppose I put x as 100, this becomes 200, this becomes 100. I'll have four zeros. I don't have four also. I just have two zeros. This is a tens, this also has to be a tens. So that this ends up at 1 0. This also ends up at 1 0. Ultimately, you have two zeros. Imagine what cat wants us to do there. That is what cat wanted us to do here. Yes or no? So everybody comfortable? This has to be something like tens. Maybe 10, 20, 30, 40, 50, 60. I don't know. Yes or no? But definitely it has to be something of tens. Now, what if I put a 10 here? What if I put a 10 here? It becomes 290. 290 has a prime number 29 in it. I cannot handle 29. I just need 2s and 3s. It has to be some 10 which eventually have only 2s and 3s apart that 0. If I put 20 as x, this becomes 280. 280 means I have a 14. 14 means I have a 7. 280 has a 7 as a factor. I don't have 7. Yes or no? Correct? Now think what it can be. It has to be a multiple of 30, right? Why? Because if I bring in 30, this is a multiple of 30. This is also multiple of 30. Eventually, you will get a multiple of 30. That means so many 3s. Great. Let's try to put in 30. If it works, fine. Otherwise, I'll directly jump to 60 now. Then I directly jump to 90 now. Put 30. If I put 30, this is 270. This is 240. Two zeros settle. This is 8 into 3. So 2 cube and a 3. This is 3 cube. Oh my god. 2 cube, 3 cube, 3. 2 cube, 3 cube, 3 and 2 zeros. We are done. X is 30. Spot on. Game over. Yes. If 30 would have not worked, I would have tried 60. That is how I would have gone. 30, 60, 90, 120 and I'm sure I would have got the answer. Why? Because this is 216. Yes. So you cannot go very less, right? This x cannot be very high. Correct or not? Eventually, this is 216x can never surpass 45. Because then 2 into 45 would be 90. Water entering would be 90 itself. So x can never surpass 45. That is also one thing which I observed. But now, the point is, we took some more time. You might be thinking we could have done it by calculation quadratic. Now imagine once you have those approaches now, then you don't take time. I'm explaining to you. That is why I'm taking time. Otherwise, writing 4 lines, how much time would have it taken? Me or you once you know all these things. So if you ask me, I would have done this calculation after this within another 15 seconds or 12 seconds. Why we are taking more time? Because I'm explaining you. That simple. Right or not? And now imagine if there were options. I would have directly jumped to those options which were ending in 0. Yes or no? Now, if you think that we can handle this by the quadratic equation faster, try. You will eventually come back to this only. Yeah, that is too long. Right. So let's jump to the next question. The idea is how much you write is going to determine how much time do you take. If I am explaining, so even, a 30-second question can take 10 minutes because I'm explaining you. Yes or no? Let's go. Chalo. Try this one. Slowly, slowly it will happen. Slowly, slowly, right? First, you have to, get out of that comfort zone and try these approaches. Then only you will develop these. 70% of the people, they don't even try these approaches, then they never build. Because it is very easy to skip by the difficult route or a route which you are learning, and it is easy to take a route where okay, quadratic expression, eventually if splitting won't work, I'll apply discriminant rule. So you are choosing a comfort zone, and cat does not come with the comfort zone. So this one is doable, right? Direct question, work rate, time. So of course this should have been done in the second round. Why calculative? It's gonna take time. Standard procedure, but gonna take time. So let's do. Sam can complete a job in 20 days. Mohit is twice as fast as Sam and thrice as fast as Aina. What will be the rate we will assume for M, S and A? We already have a rate equation. So once we have the rate equation, we can go ahead and assume the rates, right? What will be the rates? You all have learnt it. A rate of Mohit is 2 into 3, 6. Rate of S is no coefficient, let's write 1. 1 into 3, 3. Rate of A is 2 into 1, that's 2, right? Everybody remembers this? Correct. Now the question says Sam can complete the job in 20 days. So if we give Sam 20, the works become 60, rate into time. So by far we already know the work is 60. We know that M has a rate of 6. We know S has a rate of 3. We know A has a rate of 2. Yes or no? Work 60, MSA is 6, 3 and 2. Now there is a cyclic pattern, right? What is the cyclic pattern? So I hope everybody knows this, right? How to assume the rates. Hide M, you will and multiply the coefficients, you get the rate of M. Hide S, multiply the coefficients, you get the rate of S. Hide A, multiply the coefficients, you get the rate of A. So we have this. Now they undertake a job with an arrangement where Sam, Mohit works together on the first day. Sam and Mohit for the first day. Fine. So I'll write here as well, right? So there is no confusion. Sam and Mohit works. That means 9 work has been done. Sam, Aina on the second day. All right. So second day we have Sam and Aina. Sam and Aina, that is 5. Fantastic. And then Mohit, Aina on the third day. Mohit, Aina is on the third day. And that's 6 plus 2, that's 8. And then this 3-day pattern repeats. Cycle is complete. How much work we have done? A 9, 5, 14, 8, 22. 22 work in one cycle, right? 2 cycle, 44 work, right? We have to go till 60. Then this day will come, correct? One cycle, 22 complete. Second cycle, 22 more complete, total of 44. So day 6 are over, 3 and 3, 6. Then you would come to day 7 and this will happen, 9 more work. So 44 and 9 will be down to 53 work. Day 8, this one, another 5 works would be done. That means we are done with 58 work. Day 9, we will be doing the remaining 2 work. You won't have to work for the day 9 completely, but one for the day. Right? Now, what does the question says? Fraction of total work done by Sam. So how many days Sam has come? How many days Sam has come? In each cycle, Sam came for 2 days, day 1 and day 2. So Sam must have worked 2 days here in the first cycle, 2 days here in the second cycle, right? Every cycle is coming for 2 times, not on the third day. First cycle 2 times, second cycle 2 times. Day 7 was this one, he came. Day 8 was this one, he came. Day 9, he did not come. So 1, 2, 3, 4, 5, 6. Sam worked for 6 days at his rate of 3. So Sam has finished 18 work, isn't it, guys? Simple? Easy? I'll repeat the cycle, don't worry. Sam came for 6 days at a rate of 3 he worked, 18 worked he finished. Out of how much? Out of total 60. So 18 by 60, 6 3 ja 6 10 ja D. So that's what I said, doable of course, but it is a little calculative. This much you have to do, right? to make it very clear to you, I'm writing first day, second day, third day. For if I would have writing only for myself, I would have written D1, D2, D3 and I would have done little quickly, but still it would have taken some time in the calculation, in the writing part, right? One person was asking the cycle again, I'll explain. The idea is Sam and Mohit work together on the first day. So first day, Sam and Mohit, he works at a rate of 6, he works at a rate of 9. So you're working at a rate of 9 and in one day you will do 9 into 1, 9 work. Similarly, second day you have Sam and Aina. So 3 plus 2, 5 rate, one day, 5 into 1, 5. Third day, we have 6 into 2, 8. That's the cycle. 9, 5, 14, 8, 22. So in a total, we do 22 work in one cycle. That makes 3 days and 2 for Sam. Yes? Done? Shall we go to the next one? So these were 3 arithmetic questions. So now see, how are these 3 arithmetic questions? Because the rest of the arithmetic questions were easier than this, which I've covered in the round 1. How are these arithmetic questions? Where would you grade them? Grade these questions? Doable? So now what would you call 2024 paper? Easy or tough? Easy so far, because the algebra did not come yet. So what was the crisis in 2024 was algebra, right? Great. So let's go ahead. This algebra question is from the standard pattern. If you have done functions thoroughly, or if you managed to see the algebra 2.0 marathon on the YouTube in MBA English channel, then also we have discussed this pattern, right? So this question should be in the round 1 for the people who have seen this pattern, but for the people who have not seen this pattern and it is a new question for them, then it should be in the round 2. Try. No, Naman, it isn't like that. Naman is saying if in question 1, B is 25, C is 70, sum exceeds 84. Naman, if you calculate A over there, it will come in the negative, right? Nowhere it was mentioned that the number cannot be negative. So A will come out to be negative there. So 70 plus 25, that's 95. A will come out to be minus 11. And that it makes 84 again. Minus 11 or minus 22, whatever. Today I have 2 classes. See, your cat is close. It has been, past 3 months I have been working on every Sunday. But now this would be, I guess, the last marathon for me. Today in English and today in English, right? And then from now on, you can prepare on your own. Thanks for all the love and all the support you have been giving me through all the portals. I was seeing a, thread on the Reddit yesterday. You guys have gone crazy. It's great to see it. Thank you so much. Means a lot, but I'll be more happier once you score and come here. Meet us. Why in English? Because I've finished all the 2024 slots. That was my target and aim, to finish 2024 slot 1, 2 and 3. Geometry I would take, right, and then see. Alright, so what about this one? Yes. So for any non-zero real numbers, fx plus 2f of 1x is equals to 3x. So I guess how many of you have seen this pattern? How many of you seen this pattern? In this pattern, what we do? We assume fx to be a, right? And f of 1 by x to be b. And this we do in our mind, right? This becomes a plus 2b equals to 3x. And the next step is to replace x by 1 by x. This, whatever I'm writing here, this is to be done in mind. We don't write these things in the paper, right? We save time. So as soon as we replace x by 1 by x, fx becomes f of 1 by x. So that means a becomes b, right? As you make the replacement, they interchange. So a becomes b and b becomes 2a. X has been shifted to 1 by x. This becomes 3 by x, right? Very obvious. If we put x as 1 by x, this becomes f of 1 by x. That means b. If we put x as 1 by x, this becomes f of 1 upon 1 by x, that is fx, which is eventually a. So this we can do in our mind. This can happen within 5 seconds. A plus 2b 3x, replace b plus 2a 3 by x. Yes. We need to find out a because we are in the hunt of fx. So let's eliminate b. So I'm substituting a plus 2 times. What is b? B is 3 by x minus 2a, right? If this goes over, this becomes 3 by x minus 2a as b, eventually as 3x. Done. Substituted value of b in the first equation, so minus 4a and a, that's minus 3a, plus 6 by x equals to 3 by x. 3a goes over there, this becomes 6 by x minus 3x. Let's take away 3 as well and replace a by fx. So a becomes fx, 3 cancels out. This becomes 2 by x minus x. Yes. Everybody here in the 4 lines? And now what is it? Then the sum of the possible values of x for which fx equals to 3. Next question is going to be very beautiful question, guys. My favorite question of the entire CAT 2024 all slots. So fx is 3, 2 by x minus x, right? Now the question says sum of all the possible values of x. Let's take the LCM, take it over here. We have 3x equals to 2 minus x square. Eventually x square plus 3x minus 2 equal to 0. Sum of values of x minus b by a, that's minus 3, right? So rest is all calculation. What is important is we put fx as a, f of 1 by x as b in our mind. This equation becomes a plus 2b as 3x. Replace x by 1 by x, a jumps to b, b jumps to a, x, change it by 1 by x, 3 by x. Eliminate b to get a, either by substitution or elimination. Once you get a, that is fx. So this a is nothing but fx. Now you know fx. Now he can create any question whatever he wants. He may ask you f of 4, f of 6, and this time he says fx equals to 3 for vertex. So we placed fx as 3. For vertex, it's a quadratic. So this is a quadratic we have to satisfy. Done? Simple. Wanna try the next one? Majority of you would say the next one to be left. But eventually, you have done that question. But you won't realize that you have done that question. Do you want to see it? Geometry today 7 beta. Have a look at this one. Should be done in the round 2 or should be left in the round 2? Tell me. One crazy thing is going to happen here. Crazy thing which is not out yet on the internet. I have not taken this sum in any of the classes. Left for the last day because I guess now only you would be doing it. Round 2, how to do it? What's the best way to do it? What's the best way to do it? See, there is one simple way of doing it, but that is lengthy. Assuming x to be greater than 2, then assuming x to be between minus 2 and 2, then to do it as x to be less than minus 2, making 3 cases. Yes. Let's focus on the left side. Imagine what it is written on the left side. If x is greater than 2, let us say if x is greater than 2, I'm just talking about the left side, right? To make you realize something. If x is greater than 2, what does this becomes? Maximum of x and 2 would be x because x is greater than 2. Minimum of x and 2 is 2 because x is greater than 2. So minimum is this one, right? Smaller is this, right? And what if x is less than 2? Then maximum would be 2 because x is less. And minimum would be x because x is less. What is this function actually written? Think. This is not something which it looks like max and min function. No. Which function follows these things? If x is greater than 2, then we have x minus 2, x is less than 2, it is 2 minus x. What is this function written on the left hand side? Think. What else function do you write in this way? If x greater than 2, it is x minus 2, x less than 2, it is 2 minus x. A function that is changing sign at the critical case 2. Think. A function that is changing sign at the critical case 2. If you go past 2, it becomes x minus 2. If you go less than 2, it becomes 2 minus. It is a mod function. It is not a max-min function. Think. This is nothing but written as mod of x minus 2 in a fancy way. If x is greater than 2, this becomes 2x minus 2. If x is less than 2, quantity inside becomes negative. And ultimately it is 2 minus x. So they are writing the mod function in a fancy way such that it does not even visible to the students. That is what they played with. Now the idea is, open up this function, you will realize that they work in the very same way. Take your time, open. How would you open x minus 2? You would say if x is greater than 2, then the quantity inside modulus is positive. So it has to be x minus 2. If x is less than 2, the quantity inside modulus is negative. So this is 2 minus x. Now forget about the mod. Have a look at this. It says choose which is maximum. So if x is greater than 2, which is maximum? X, because this is greater than 2. So this becomes x. What is minimum between x and 2? 2, because x is greater than 2, you have assumed. So minus 2. So do you say mod and this function opens up as x minus 2 in when x is greater than 2? Yes or no? Or now imagine, what does this means? Difference between x and 2? That also positive difference between x and 2? Think. When you are picking up the maximum of x and 2, so you are taking the larger one. And then you are picking up minimum of x and 2. That means you are subtracting the smaller one from the larger one among the two people x and 2. Yes or no? Think. So this represents difference between x and 2. Yes or not? What is the meaning of modulus? Difference between x and 2. So do you realize that this is nothing but a fancy way of writing x minus 2? Right? So if you can't visualize through equations, visualize through here. This simply means positive difference between x and 2. Yes or no? You're taking the larger one, subtracting the smaller one. So it's a positive difference. What else is the positive difference? Mod. So basically this function is nothing but mod of x minus 2. And the right hand side is already crazy. So that means we have mod of x plus 2 minus 2 times mod of x minus 2 is equals to 0. You know how to draw the graph, isn't it? You know how to draw the graph. Draw the graph, end it up. Here is the graph. Critical cases minus 2 and 2. The value at 2, this becomes 0, 2 plus 2, 4. Positive 4, so above this line. Add minus 2 plus 2, 0, minus 2 minus 2, minus 4. Becomes 4 into minus 2, minus 8. Negative, so below the graph. Something like this. Sum of the coefficients 1 minus 2 minus 1, so goes down, goes down. We want equal to 0. That means on this line, one solution, two solution answer. Now see how much have we written if attempted in the right way. That's what CAT wants us to see. In the round 2, if we want to maximize the attempts, the visualization power, the approaches need to be superb. How much did we write? Did you even imagine that we'll be writing just 2 lines and a graph for this question? Imagine opening up the graph greater than 2, less than 2, less than minus 2, between minus 2 and 2. And if we, let us say, made a mess in one of the area, -2 to 2. Everything would go waste. In this kind of thing, it is very difficult to make a mistake, but it is very difficult to come to this as well. But now for the next time, you would realize this function, right? So for the next time, if I give you something like this, maximum of x and y minus minimum of x and y, this simply means mod of x minus y. You are talking about the positive difference between the two. If you catch this step, rest is very easy. CAT is about the smart questions where you just need to catch one step and then the algebra opens up. Yes or no? Correct. So this question has a separate aura. That's why I said this was one of my favorite question of all the three slots, right? Something very new, right? So try this one. Yes, the pen went flying after seeing such crazy level question. That's what happens when we go in so much of flow when it is about mathematics and some new things. -2. ये क्या हुआ? Alright, what happened? The pen flew off my hand. I was so much into the feel. I did like this and the pen went off. Launch pad for the pen. So try this one. See, Samuel will do one thing. Let me just put it in this way. Maximum of 5 and 2 minus minimum of 5 and 2. What happens? This becomes 5 minus 2, isn't it? So what have you done? You have taken the difference between the two and that to the positive difference, yes or no? So what happens if I replace this by x and if I replace this by x, again you are asking me to calculate the positive difference between x minus 2, right? But I don't know what is the positive difference. Is it x minus 2 or 2 minus x? So to save myself, I put a mod. So that now eventually the difference always comes out positive. Done? Sorted now? Simplified? Correct? That's it. Alright. 8. So you know the graph of this? See, the idea is this graph, some of the students already know, right? The graph of this is simply, put y equals to 0, then put x equals to 0. You will get the feel of the graph a little bit, then you will have to complete it. But I'll teach you how to draw the entire graph as well, right? First, let's put y equals to 0. What happens? If I put y equals to 0, this becomes mod x plus mod x equals to 2. 2 mod x equals to 2 or mod x equal to 1. That means x equals to plus minus 1. So if y is 0, that means x is 1. So what solution we have? 1 comma 0, 1 point here, minus 1 comma 0, 1 point here, right? Correct? So this is when you have assumed y to be 0. So 2 points that comes out to be 1 comma 0, minus 1 comma 0. Similarly, if you put x equals to 0, you will get symmetric 2 points. See, modulus is very symmetric function, right? Now the only possibility is either this will be something like this or it will be something like this. Now how to check whether this is this or this? Put this point. This is 1 comma 1. See if it satisfies, then this is the line. If it does not satisfy, then this is the line. They are very symmetric. Now once you put 1 comma 1, this will satisfy. That means this represents a square. So if somebody knows it, you can remember this graph. If you don't know it and you're seeing it for the first time, how would you draw it? You need to know coordinate geometry then. So do you want to see that if I would have not known and I don't want to go with the putting number method, what is the way to draw the graph? Do you want to see? But you should know the basic drawing of the line at least then in the coordinate geometry. So if you know that, I can show you, right? Now the number of points is quite easy. We have 1 comma 1, so we have this also, that is 1 comma minus 1. We have a minus 1 comma minus 1. We have this one, that is minus 1 comma 1. So 1 2 3 4 5 6 7 8 8. If this would have been less than equal to 2, then this will also come. But right now it is equality, so only 8, otherwise 9, right? Right now it's 8. Now see, how can we draw this graph if we, let us say, don't want to put in the numbers? How to open the mod? I need to know the relation between x and y. So what I am doing is, I am just drawing it for the first quadrant. So I want x and y positive, right? Because whatever comes here, I will replicate it on all the 4 quadrants because I know that it is symmetric for sure. So I'm going to draw just first quadrant. Now I thought, okay, x and y positive, so let's draw for this quadrant. This definitely becomes positive, opens as it is because both are positive, we have assumed. But what about this one? This is x minus y. What about this one? So I have to assume that x is greater than y. So I'm also assuming x is greater than y. Now x is greater than y in this region, below this 45-degree region, right? See, here if you put any point, correct? Let us say here, so this will be somewhere like 2 comma 1. 2 comma 2 lies on here on the x equal to y line. Now this much you should know that if x is greater than y, you're talking about this region. Below this region, y is higher. You can visualize this as well, right? This point x is very far, y is just a little thing. So I'm gonna try for x greater than y. This opens as positive again because I've assumed x greater than y. I get 2x equals to 2x equals to 1. So for this region, I get a graph something like this. Did you get this part? This is the graph of x equal to 1. Do you get this part? What I've assumed, xy greater than 0, x greater than y. So I'm looking for this region. First quadrant for sure, x greater than y, below the line of x equal to y. So I put these two things, open the modulus as per them, x comes out to be 1, so line of x equals to 1. Now it is simple. Take the mirror image of this, right? The mirror image of this on the line x equals to y is going to be something like this, right? Mirror. Now take it like this, because you have the one quadrant, this becomes the mirror image of this becomes the mirror image of this becomes the mirror image of this. You will come to eventually a square. That's how you draw. But of course, this becomes difficult within the paper. So you should remember this graph. If you know it, great. Otherwise, that, the method by just putting the value method. I put x equals to 0, y equals to 0. I got these 4 points. The only thing that was left in my mind was, is it this graph or this graph? So I thought, let's check 1 comma 1. If it satisfies, it's this graph. If it does not, then it is a green graph. So totally up to you by which way you wish to go. This or this. Okay. Eventually you have to go with a square. Done. Perfect. Because I tried 1 comma 1 Aviral. Okay. So 1 comma 1 won't come to the rhombus. Perfect. Chalo. Now guys, our rest were easy. We have done 6 modern math question. Would you have done this? Now guys, would you have done this? See, first one is easy for sure, but you don't know na. Daily you get the same function. Maybe on a certain day you get a random new function where you're not able to identify the symmetry as well. Then what would work? The basic method, the fundamental method of growing the work. So this not to be done. Okay. Try now once. Try now. No. Majority says no. Okay. So just let's check this one. This one in the second round. Let me just check whether you choose the best one or not. Right. This one in the second round. Would you have done? So we have to wait 3 more to go. Choose the best one. We'll do that first. I'm in the slot 2 beta. I don't know I'm going to give or not. No. Yes. No. Okay. Remember the numbers you wish to do, alright? At the end you will tell me. We'll see what numbers pops up more. 8. This is the 9th one. Geometry. This one to be done or no? This one to be done? Yeah, very easy. That was Venn diagram. Simple. Sabko no bol rahe. You're telling everyone as no now. Come on. So very easy. Right, this is a clear yes. Try this out. A clear yes. We can't let this kind of questions go. They are new, yes. That's why I kept in the round 2. It's very, very doable. Right? Midpoints of AB, BC and AC are M and P. So don't we know the relation, guys? Random triangle. And in fact, if it is a theta question, this works for every triangle. You assume it to be an equilateral triangle. How does it matter? If the certain thing has to be true for any triangle, this definitely will be true for equilateral triangle. So let's assume it. So A, B, C, M N and P are respectively the medians from ABC intersect the line MP, MN and all, right. So we have the medians. So that means X, Y, Z are the center points. What happened, guys, when they are the central points? What is the area of this? Isn't it 1/4? Remember, all the triangles are divided into equal parts. This becomes 1/4. And then similarly, what you're talking about is that we have MP, MN and all that, and then we have X, Y, Z, right? So basically, these points are M and N, P, right? So M and, okay, what are AB से M, BC से N, BC से N जा रहा है, and then we have P. And then the median would be coming something like this. So this point becomes X. Median would be coming something like this. This point is Y. Median would be coming something like this. This point is Z. So we already have 1/4. Another 1/4. So can we say 1/16th? This is 1/4. This is 1/4 of this. So if we talk about MNP, that is 1/4 of 1440. This is MNP. XYZ is another 1/4. Yes or no? How simple? 16 and 9 are 90 is the answer. 2 lines you're done, just the right figure. Why to leave such things? Yes, they might come in round 2 because, you know, some of you don't see geometry, specifically when it is a long question. Rishi is catching each and every line I speak in Hindi. It will take some time, Rishi. I have been teaching for the past 3 years straight away in the Hindi. Yes, without pen paper question, alright. Oh, what about this one? Will you do it or not? That was the easiest geometry, although. Will you do this one or not? Skip. Alright, next one is definitely for skip. So now let's come back and start in the order we were doing. So this was the one which we, you know, started choosing. What about this one? Now let's try it up. It is a simple question, guys. If you try it, it is a simple question. See, it says group of 250 students, percentage of girls were at least 44 and at most 60. So we have 250 students, right? And now in these, we know that girls are 44% to 60%. Eventually, we'll get the boys. Tell me what are the range of girls? What is the range of girls? 44% of 250, how much? 44% of 250, how much? See, 40% of 250 is 2 by 5, that is 550 is 100. So 40% is 100, 4% is 10, that means 110. 2, 60% is 3 by 5, 50, 3 is 150. So the girls' number range from 110 to 150, right? Right. So if I talk about the girls, minimum is 110, maximum is 150. What about the boys, guys, then? What will be the number of boys then? See, that will determine the number of boys. If total is 250 and girls turn out to be maximum, that is 150, then the boys will be minimum. So if girls turn out to be 150, 250 by 150, they will be 100, right? Similarly, if girls turn out to be 110, boys will be 250 minus 110, that's 140, right? So the best case scenario for girls is girls becomes 150 and boys becomes 100 when the girls are maximum. And the worst case scenario for the girls is when girls becomes 110, boys becomes 140. Yes or no? So this is the worst scenario for the number of girls. They are minimum. This is the maximum number of girls, right, guys? Yes. That is what we have. Now jump to the next part. Right? Now jump to the next part. It says each student opted for swimming or running or both. Fine. So this we'll draw for boys. This we'll draw for girls. We have swimming and running. We have swimming and running. Fine. Solve. What it says, 50% of the boys and 80% of the girls opted for swimming. So boys in the swimming, 50%. Girls in the swimming, 80%. Next, it says 70% of the boys and 60% of the girls opted for running. 70% of the boys, 60% of the girls. Fantastic. Max and minimum possible number of students who opted for swimming and running, both. How many boys opted for swimming and running both? How many opted for swimming and running both? 70, 50, 120. Extra is 20. So this part is 20 for boys. 80, 60, 140. Extra is 40. That means this is 40% for girls. Yes or no? Simple. So whatever is extra apart from 100, that is the central part that has been overlapped, came twice, right? 20, 40. And now, this means we have 20% of the boys plus 40% of the girls who are doing both. Now in this scenario, we will get the maximum number of students doing that. Why? Because the major percentage making both the sports is girls. So the more the girls, the higher the percentage of girls. Boys is just 20%. They don't matter at this point of time. In this particular question, don't start in the chat, men life also matter. I'm talking about this question, the boys does not matter. Why? Because the area which we are looking for is dominated by girls, 40% of girls, right? So of course, if girls are more, we'll get the maximum. If the girls are least, we get the minimum. So we just need to calculate this and we are done, guys. If you smartly calculate percentage, it will be easy. 20% of boys. Boys were 100, that means 20. 40% of girls, how much? So 2 by 5, 530, 60, right? 2 by 5, 530 is 60. So that means 80 is the max. So 80 max is only one possibility. Answer D. We don't even have to calculate the other one. Yes. Easy. Simple. Even if you go ahead and calculate, you will get 72 fine, but I don't need it. Maximum is 80. I'm already done, guys. Yes or no? So that is why I chose the maximum, because I already seen the options. I knew that if I calculate minimum, it comes out to be 72. I won't be able to determine whether it is A and D. These things also matter. Yes or no? Did you see this little thing what I observed? I thought if I would calculate minimum, if it comes out to be 75, I'll be stuck between these two. If it comes out to be 72, I'll stuck between these two. But if it comes out to be 80, 96, 90, 88, I will be very sure. I won't have to calculate this. Yes or no? Remember, options are also the part of the questions. You can take the help of them. Yeah, sure. Let's go to the next one, guys. Have a look at this one. It will come out to be 72 for sure. Else the question would have to be bonus then. Keep that attitude in the last 10 days. What you need is just a positive aura around yourself. That's it. In the last 10 days, what matters is how are we feeling. The extra, extra things comes into the picture in the last 10 days. How we are feeling. How is our sleep cycle? Am I fit or not? I'm feeling good or not? Am I healthy or not? Right? I'm feeling energetic or not? All these things does play a very crucial role in the last 10-15 days, right? No panic whatsoever, just chill, enjoy. I don't mean that you just stop studying. I mean just study, but relax. Whatever happens will happen. Now just relax, keep doing it. Keep doing whatever you've been doing so far. What about this one? Consider this sequence. We are given with T2. We already know that we are interested in only the even terms. Tn is related to the second consecutive term that is behind it. So let's calculate T4. If I put n as 4, so 4 minus 3 is 1, 4 minus 1 is 3, this is 4 minus 2. The term which is 2 behind this, so 2 behind this is T2. That's 1 by 3, T2 is known to us, that's minus 1. So T4 comes out to be minus 1 by 3. Similarly calculate T6 and you will see the pattern. Yes, be very careful that you don't exhaust yourself, Rakshita, at the end of the day, right? Sometimes people do too much in the last 10 days so that they don't feel like solving the questions or reading a passage in the last exam day because mind is exhausted. Even if we do anything which is of our interest and keep doing it for a longer duration, we feel bored, right? So make sure that you don't exhaust yourself. What about T5? T5 we don't need to calculate. T6. 6 minus 3, that's 3. 6 minus 1, that's 5. Term 2 behind this is term 4. That's minus 1 by 3. And now we realize that, okay, they cancel like this and we get minus 1 by 5. I hope now you must have realized what's happening, right? In case you haven't calculated one more and T8 comes out to be minus 1 by 7, then eventually you will realize. So what do we have? We have T2 as minus 1, or we can say minus 1 by 1. We have T4, we have calculated minus 1 by 3. We have T6, we have calculated minus 1 by 5. Then we have analyzed the pattern which is minus 1 by 7. Best part, question is reciprocating them. We have a AP or a pattern in the denominator. You reciprocate it, made the things easy. So what would be 1 by T2? Reciprocal of this, that's minus 1. 1 by T4, reciprocal of this, that's minus 3. 1 by T6, reciprocal of this, that's minus 5. 1 by T8, reciprocal of this, that is minus 7. And when I keep adding them, minus comes common. I have 1 plus 3 plus 5 plus 7 dot 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 dot. How many terms? How many terms, guys? Yes, how many terms? So we have 2 1 ja 2 1 0 1 2. Starting from 2 into 1, going to 2 into 1 0 1 2. So we have 1012 terms, right? So these are 1012 terms. Do you know the direct formula for this? 1012 square. So for the odd terms, you have n square, right? So if you have number of odd terms, you square it up directly. For even it is n into n plus 1. For odd it is n square. If you know that, fine. Otherwise apply AP formula. So n square, 1012 square. See how smartly can we do the square. Add 12 to it. It is 12 more than 1000. add 12 to this, so 1024, then 12 ka square is 144. That's the answer, guys. 1024, 144. Cat is smart. He is not going to give you a random number. He knows how to involve calculation so that if a person knows the basic tricks of calculation, he can handle. Minus because there was a minus. Yeah. Done. You can do by AP formula, n by 2a1, 2a1 plus n minus 1d. You already know the n, right? Clear? Set? Alright, so these were two modern math questions. So guys, what would you say about these 11 questions? Do you find them hard or do you find them doable in the second round? And if not all, of course, do you think that if you tackle those 11 questions in 30-32 minutes, in the next 8 minutes, how many will you be able to do in these round 2? How many will you be able to do this in the round 2? If, let us say, see, of course, time also plays a major factor, guys. You can do all 22, I am very sure, and I am proud of you for that. But time should be infinite, na then. If we open up the time, then doing those 11 questions, hunting them, and then finishing them, getting to the answer takes away 30 to 32 minutes. Next 8 minutes, how many can you do? 2 to 3. So that means we are already to 11 to 14. That's great. 11 to 14 will fetch you around 99.5, 99.8, 99.9 percentiles. Superb. Alright, this one we did. What about this one, guys? Yeah, 2024 Vedamitra. 2024 slot 3 difficult questions. The rest 11 which you have already solved are on this channel, which were easier than this. So what about this one? Doable? Alright. Eventually we'll have to solve it now. A circular plot of land is divided into two regions by a chord. So we have a circular plot divided by a chord of length 10 root 3 in two regions, region 1, region 2, such that the chords obtain 120 degree. Fantastic. Then the area in square meter of the smaller region. Alright, so we are looking for this minor segment, right? So we definitely know that we need to calculate the area of sector. 120 by 360, that is 1/3 pi r square, minus the area of the triangle, which is going to be half r square sine theta. Correct. So all we need to calculate is r square. If we get the r, rest all we know. Sine 120 is sine 60, right? You need to know the trigonometry for this one, right? Sine 120 is equal to the sine of supplementary angle to this. So that is 160, right? Now all you need to do is find r. For that also we need some trigonometry. If we drop this perpendicular and bring this triangle out, this is half of 10 root 3, 5 root 3, perpendicular from the chords bisects the chord. This angle is going to go half and this is r. Apply sine 60. So of course you need to know a little bit of trigonometry for this. Sine 60 is perpendicular upon hypotenuse. So sine 60 is root 3 by 2, 5 root 3 by r. This gets cancelled. R comes out to be 10. So only to be picked up if you know trigonometry, if you have done trigonometry. If you have not, leave it for now. Right? So this is 10 and eventually this is 1 by 3 pi into 10 square is 100 minus half r square is 100. Sine 60 is root 3 by 2. So 2 and 2, 4 makes it 25. 25 common. You have 4 pi by 3 minus root 3. That's option B for Bartla. Not difficult, but only to be done if you know trigonometry. How many of you have left trigonometry? See, if you don't know the trigonometry, you won't be able to find out R. It will require trigonometry, right? or at least you should know that this 60° 90° angle has 1√32 as the ratio, then you can do it. But eventually you will have to leave it if you don't know trigonometry. This comes from the trigonometry part, this comes from the trigonometry part. Left, so it's okay. Now I won't recommend that at the end of the day you start doing it. You know, in 2024 slot 1, slot 2 trigonometry was not used, slot 3 in one question it was used. So in these kind of cases you will have to leave this question. Not possible that out of 22 3 or 4 comes out based on trigonometry, right? 2024 slot 3, eventually 2 of the geometry question came out from trigonometry. All right, so one last question, right? One last question, right? And then I'll hand it to Surana sir. Okay, then I'll hand it to Surana sir. Make sure that he's asking smaller region, so minus, otherwise the answer would have been plus. This also required you to do a little bit of trigonometry. A regular octagon ABCDEFG has sides of length this, then the area of the square. Now see, it suddenly came an octagon. Not before this we have ever seen octagon in the past 5-6 years in CAT. So 2024 was the first time we saw octagon, that also in the slot 3. Alright. So first thing is you need to know the vertex angle of octagon. Please calculate it for me. Apply n minus 2 into 180 upon n, or find 360 by 8 exterior angle, subtract it by 180, right? So what is the vertex angle? So it says ACEG we need to calculate, right? So let's just put it ABCDEFG. So we are looking for this diagonal, right? This eventually is going to be a square. Two sides, then this length, two sides this length, two sides this length, two sides this length, angle same. So this is going to be a square. I just need to calculate this x. I know that these sides are 6. Right? If I calculate x, I know the area is going to be x square. Right? By symmetry, we can clearly say all of them are going to be simple, same. Side 135, angle 135. So if this is 135, just apply the cosine rule and you are done. And then eventually we'll call Surana sir without any break, so that you can maximize your time. Solve it up. 135. Apply cosine rule. Do you know cosine rule? Cos 135 equals to 6 square plus 6 square. Square of the sides making this angle minus opposite side square upon 2 into product of the sides making this angle. Right? So if you want to remember it, cos 135 is sum of the squares of the side that made this angle minus the square of the opposite side upon 2 into product of the sides making this angle. That's the formula. 6 square plus 6 square minus x square upon 2 into 6 into 6. And cos 135 is again very similar to sine. Cos of supplementary angle of this, but this time with a minus sign. In sine, it would have been sine 45 without a minus sign. So this is 72 minus x square. That is what you need to calculate upon 72. This is minus 1 by root 2. So trigonometry comes into the picture, as I have already said, only to be done if it is a trigonometry. If you have covered trigonometry, right? So this becomes minus 36 root 2 equals to 72 minus x square. X square comes here, 36 root 2 plus 72. 36 common, and we have root 2 plus 2. And the answer is D. So only if you know trigonometry, otherwise you will have to leave. So guys, this brings us to the end. I've left the solutions for you if you wish to try these questions of trigonometry. Now I'll shift to Surana sir. He'll be taking the LRDI sets, and I'm very sure they are going to be very, very helpful. How many would you have done now if I give you 40 minutes? You have seen the 11 easy questions, then tell me. How many? Acha, on this very channel, you can find out all the 2024 slot 1, slot 2, slot 3 complete. Every video has been broken into two parts: doable questions, non-doable, or to be left question. I won't say non-doable, you can do them if the time is given, right? Then those questions which were there to be left, right, because of the time. How many? Thank you guys, thank you so much, right? 9 to 10, that's nice, that's nice. In the night, we are meeting for the geometry marathon. One more news, you will find the Google form where you can submit your admit cards. That will help us to reach you out once you get the good scores, so we can help you in the counseling sessions and selecting the top B schools as per the score you get, right? So make sure you fill that. Secondly, Suran sir is going to come in the night, 7 p.m. Let's meet for geometry, all formulas and all the list. Gonna be, I guess, the last marathon for me on the English channel as well. We've already covered entire algebra and arithmetic. Now it is the time that I give you the geometry cheat sheet, and it is up to you now how to revise, what to be left, what to be done on the priority. Spend the last 6-7 days with your own self. In the end, don't make it too heavy. Long sessions of 6 hours, 7 hours does not work in the last 7-8 days. Keep it that your time of those 7-8 days depends more on what you have done in the past time and how do you wish to feel on those last 7 days. Don't try to panic, don't think too much. As soon as that overthinking comes, pick up any particular topic of any particular subject which you feel you are good at. Once you start making some good questions, you will feel better, you will feel confident. Okay, chalo, I'll just give a call to the YTM. That is it. My time is over for this particular session, and Suran sir will come into the picture. Take care, guys. Bye bye, and have a good day. Session as well. See you.
Hello, folks. What's up, everybody? Good afternoon. How are you doing this fine Sunday afternoon? Good afternoon, everyone. Hello. I guess you had a good time with Rahul, sir. Yeah, great. All right. So let's begin with DILR then. Yeah, let's go. Done. Great then. Let's begin. So now that your cons is over, I think we'll have to slow down the pace a little bit because you can't be that quick with DILR. The aim itself is to answer 50% of the questions and a little more if possible. Yeah, let's go. Good afternoon. So today we're going to focus on this topic called maps and networks. There's a lot of rumor, or I'd rather say talk around this topic, that there'd be more questions from maps and networks. And I don't think that's something new. Like, we have seen questions from maps and networks come across different slots in the, at least in the last 10 years. If you see, you come across at least one question that was maps and networks based in one of the years for sure, right? Yeah. Cool. So how many people like maps and networks, man? Let me first ask you this. Do you like it or do you not like it? Quick, let me see this. How many people like maps and networks and how many people don't like it, or even worse, hate it? Yeah. Let's go. Hate, like. Yeah, a good mix of both, right? Because over the years, the kind of questions that we have seen from maps and networks, most of them have been either in the easy or moderate zone. Very difficult maps and networks questions, there have hardly been any. But the problem with maps and networks, especially in a test environment, is you won't be able to come up with all the possibilities, that there are so many cases for a person to start from one place and reach to the other place. There's so many cases, so many possibilities, that it becomes a little tricky at that time to keep in mind all the possibilities, right? That's the only problem with maps and networks. Otherwise, it's a cutie of a topic. You can always try to come up with the solution. If you are real creative with it, then you can come up with the solution even quicker, right? So that's the advantage here. Sometimes it is time consuming, I'll give you that, Anubhav. Definitely it is a little time consuming if you don't think in the right direction, that is. Otherwise, if you know that one spot that you can catch up to, and you just hold on to that one concept or one small approach of it, and then you can build the entire set around it. Yeah, let's go. So we'll begin. So technically we'll be looking at 5 sets today. I know 5 is a little too much, but we'll see what we can do with it, right? There are 5 sets. We'll start off with the analysis first. We'll go through all the 5 sets. We'll identify what are the pros and cons of each of the set. We'll identify what kind of bay we are going to get. Is it going to be a complete bay or an incomplete bay, or are we getting multiple cases, or would we end up with no bay at all? Because most of the maps and networks questions would rely clearly upon how you are able to either draw the map on your paper or make do with the map given there, if at all a map is given. Okay, yeah. I no surprise per se, but obviously there will be one set that we will be skipping, and I think you will know which set that is going to be. Okay, yeah, let's go, let's begin then. Yeah, these are all previous year questions. These are all previous year questions from different years. So even if you have if you've not done it, obviously that's going to be beneficial for you. But if you have already done it, even then do watch it, because you'll find a different approach, a new approach, probably a more efficient one to solve it. Okay. Yeah, the metro one, I did not even bring the metro one in these 5, because that one is a real pain in our neck. We are not going to even look at it, because it's way too complicated and too time consuming for the test environment. So obviously not. Well, let's go. Shall we? Okay, so this is set 1. This is from CAT 19 slot 1. Let's have a quick look at it. So this is a set. Yeah. How many of you have done this? How many of you have seen this? Let's see. The figure below shows the street map for a certain region with the street intersections marked A through I. So these are all intersections, right? A till I. So there are 4, 8, 12 intersections basically till L, not I. This is L. Okay, this is L. So there are 12 intersections. They're saying that a person standing at an intersection can see along the straight lines to other intersections that are in her line of sight and all other people standing at these intersections, right? So basically what they're telling is, if a person is standing somewhere, let's say if a person is standing at F, for example, yes, if a person is standing at F, this person can see anybody who's in the same line. So F, anybody standing at F can see a person at E, can see a person at G, can see a person at B, can see a person at J also. Along with that, what they're saying is, and all other people standing at these intersections. So all other people also, that means somebody standing at F can not only see G, but also H. Got it? Because it's in the same line. So all straight lines, that will be clearly visible. Cool? Done? Yeah, this one is definitely a doable set, provided you're comfortable with arrangements, because this is not pure maps question. This is maps plus arrangements, because that's basically what you're doing here, right? What you're doing here is, so we'll have a look at the example also given to us. They're saying that, for example, a person standing at intersection G. So if someone is standing at G, can see all people standing at B. Why B? Because it's in the straight line. So this is the only place where we have a diagonal line. Nowhere else there is diagonal line. So if someone is standing at F, they cannot see A. Understood? But someone standing at G can see B, because there's a line going here. Nowhere else do we have diagonal lines. Okay, done? So this person can see B, this person can see C, this person can see E, who's here, can see F, who's here, can see H who is here, can see K as well. Got it? So irrespective of if someone else is also standing, that person can see through them. So at G, if someone is standing at F, it doesn't matter. This G person can see E also. Cool? Done? Perfect. Next, so the main purpose of this question is to one, understand this map and use this to place these 6 people who are standing at different intersections. Now what's the tricky part here is, there are 12 intersections, but there are only 6 people to be arranged. Right? So the idea is to identify where these 6 people are standing and also identify which of the other 6 are empty. Right? Other 6 intersections are going to be empty. So we need to identify that also and do the arrangement. Cool? Done. So let's have a look at the question. Laksh, that's what we are working on at this moment, Laksh. I'm teaching you how to look at a set and how to understand whether this set is a doable one or not. So right now, there's nothing too complicated with the map. So map part is done. We have to focus on the arrangement bit here. So if you are someone who's comfortable with arrangements, you can definitely do this set. Okay. Let's have a look at the questions. Let's do a quick analysis on the questions, identify which of the questions are of what type, and do they help us identify if we'll be getting a proper arrangement, a complete bay or an incomplete bay. We'll see that. Yeah. Have a look at it. Who's standing at intersection A? A very definite question. Yes. They're asking at A, who is standing? So if I can find out this bit, I can answer this question. Next, who can we see? That means not we as in us, W-E-V, no, the person V. So the person V will be standing somewhere. Let's say if the person V is standing here, then that person will be able to see anybody who's at intersection C, B, A, H and L, like that. So we need to identify V's position through which we'll be able to. So unless and until we are able to draw the entire bay, get the entire map figured out and the arrangement, we won't be able to answer this. This is also a definite question. What is the minimum number? So this one, although looks like an indefinite question, it is an indefinite question, but what is it asking? What is the minimum number of street segments that X must cross to reach Y? So to go from X to Y, first we need to know where X and Y are placed. So X and Y should have a definite spot, and from X to Y, what would be the minimum number of intersections that we have to travel? Next, should a new person stand at intersection D? That means there's no one standing at D, which is clearly given here. Right? No one among the 6 is standing at D. So this intersection D is empty. They're asking if a new person comes here. So this is an extension question. From the analysis of this, tell me, can you find a complete bay, or will you have multiple cases, or will you have an incomplete one? Because as far as intersection A is concerned, as far as the person V is concerned, as far as X and Y are concerned, we clearly should be able to complete that arrangement to be able to answer it. So from the question, we know that it's going to be a complete bay, and using this, we'll have to answer that. Done? The only disadvantage of this could be the number of questions, that there are only 4 questions that you can get from this particular set. But if you look at it, compared to say a 5 question set or a 6 question set that is very complicated, a 4 question set that is doable is always a better choice, because it's not just the number of attempts that matters, but also the number of attempts that you get it correct matters, right? So if you are at any time, if you are at a crossroads that you're not able to understand whether I should choose this set or that set, here there are only 4 questions, where that means the total score that I can get from there is only 12 if I get all of the 4 questions right. That same 12 question I can maybe get from a 5 set or a 5 question set or a 6 question set, even if I get 4 questions right out of them. So that decision you have to make. So with questions, there are no trouble. With the set, the only trouble is arrangement. So if you think you're not comfortable with arrangement, then this should not be on your definitely doable list, right? Otherwise, how about the set? Right, Varsha, something is better than nothing. Yes. So tell me, should you be taking this up? Yeah, this seems doable, right? If you are comfortable with arrangements, this seems doable. Yes, because it has a complete bay and the map is understandable for us, right? There's nothing too complicated with the map. So this set is doable. That means this could be in one of our top priorities. Let's have a look at the second set now. Second set is CAT 22 slot 2. Have a look at this. This one's also a map is given to us. Yes, a map is given to us and it doesn't seem too complicated, the map. But then the intro and the conditions are a little lengthy. But I think they're just trying to explain, in the first paragraph, I think they're just trying to explain what the map is all about. And only in the second paragraph will we know what they are doing. So have a look at this. It seems lengthy in terms of the reading and the understanding bit. But I think once you get into the groove of it, it should be doable, but let's see. So we'll first just analyze the map. I can see 4 corners A, B, C, D, and then there's a W which is connecting each of A, B, C, D, right? And then in terms of direct connection, there's only direct connection between these 4 like this. There's no direct connection of A to C. There's no direct connection of B to D. They have to go through W. This is something that we can understand. But there are a lot of things given to us. One, there are numbers given to us. There's, from our experience, we can say this would probably be the distance, or maybe the fuel consumption, or maybe the cost, could be anything. But along with that, at each of the corners, we've been given 2 numbers. They're saying 40 and 30%, 60 and 70%. So 40 and 60 could mean something, and this 30 and 70% could mean something else. So we will have to read the intro bit to understand what the set is actually telling. Got it? Sure, no problem, Dhruv. Okay, let's read this. So every day a widget supplier supplies widgets from the warehouse. So W is the warehouse, to 4 locations: Ahmednagar, Bikrampur, Chitrachak and Deccan Park. So ABCD. The daily demand for widgets in each location is uncertain and independent of each other. Uncertain means what? So how many widgets are required at each location is not known. At the same time, they're saying that it is independent of each other. That means the number of the amount of the number of widgets required at A has directly nothing to do with how much is required at B, C or D, like that. Okay. Demands and corresponding probability values in parentheses are given against each location in the figure below. So what is told to us is, this number is the demand, right? This 40, the 60 is the demand, but along with this, they are also squeezing in probability. Yes, the probability that the demand will be 40 at B is 30%, and the probability that the demand will be 60 is 70%. If you look at the ones in the parenthesis, the percentage value, all of them add up to 100. 30, 70, 100, 30, 70, 100, 40, 60, 100, 40, 60, 100. That means there's no third possibility. Apart from 50 or 70, there is no third possibility. It doesn't exist. Same way applies for all the 4 locations. Done? Perfect. So they've given an example here. For example, there is a 40% chance that the demand in Ahmednagar will be 50 units. There's a 40% probability, 40% chance that they would demand for 50 units of widgets, and a 60% chance that the demand will be 70. So this initially might sound a little tricky, that how are they bringing in probability into this. So you have to be comfortable with probability as well, right? Along with being comfortable with maps, you also have to be comfortable with probability. And just by looking at this, a lot of people panic, right? A lot of people panic beforehand that, oh, I'm not clear with probability. I don't know the formula for probability. I don't know what probability is, what different kind of probabilities are. This might put me in a trouble. So before you make that call, before you make that decision, you have to have a look at the questions, okay? Now we'll read through. The lines in the figure connecting the locations and warehouse represent 2-way roads connecting these places with distances in kilometer shown beside the side. So these are all 2-way roads. A to B is also possible and B to A is also possible, and the distance is 6 kilometer either which way. A to B is also 6, B to A is also 6, which is good for us. Same way for each of the locations, each of them are a 2-way road. So no 1-way road. That means you don't have to keep another constraint in mind. Okay. The distances in both directions along a road are equal. Perfect. We've already covered this. A to B is 6 kilometers. B to A is also 6 kilometers. Okay. Done. Now this bit is given to us. This bit is given to us where they are kind of explaining now. So all of this, right? All of this entire first paragraph is just explaining what this is. So here, I don't think you have to make a note of much things, or you don't have to sit and write or draw or complete any kind of a bay here, because all that you're doing here, all that they're doing here is just explaining what this map is, what are the different elements of the map. Works for us? Yeah. So this is just a reading bit, right? Like you're reading a paragraph in a passage. That's what you're doing, reading and understanding what this map is. But the actual working of the set is given here. Yeah, so we'll have to read through this to understand, but I think we've already spent enough time around this, so I think we know what we are doing here. We'll just have a look at the question. Have a look at the questions, guys. Do the quick analysis on this. What do you notice in most of it? See, if the last location visited was Ahmednagar, hypothetical, that means we don't know beforehand that what would be the last location. If the total number of widgets delivered is 250, again, if the total number of widgets is 250, so we don't even know the total number of widgets in each case, this is also hypothetical. What is the chance that total number of widgets delivered in a day is 260 units and the route ends at Bikrampur? Now understand, there could be multiple cases here, and they're asking what is the chance, what is the probability of that happening. This we can either call it a definite question or an indefinite question, but it won't affect us too much. Again, the problem here is more than a definite and an indefinite question, it is a hypothetical question, because again they are saying 260 units ending at Bikrampur. So this is no different than the first question or the second question. This is also hypothetical. Again, the fourth one, if the first location was Ahmednagar, if Ahmednagar is not the first location, so all questions are hypothetical, right? All questions are hypothetical, which tells us one thing. There is no use, there is literally no use for us to sit and draw all possible routes, correct? Why? Because the routes would depend upon either what should be the first location and the last location, or it would depend upon how many units of widgets were delivered or what was the demand, and it would also depend upon the distance. So this set is a crazy set unless and until you are very, very confident about maps as well as probability. Out of the 5 questions, how many questions are based on probability? This one is based on probability. This one is based on probability, right? So there are only 2 questions that are based on probability. So let's say even if you are not very confident with probability, out of the 5 questions, you can definitely attempt 3 if you are very, 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 very comfortable with maps, that is. Yeah. So should this be your first priority? There is definitely no bay, right? There's definitely no bay. This could mean 2 things. One, that there are multiple cases and you have to sit and work on the multiple cases, or the second one, that for each question you have to make a route that would reduce the amount of pre-work that you're doing, right? So this could be a good set. This is one of the extremes. It's either a good set or a completely bad set, nothing in between, okay? So set 2 would not be on our, definitely not be on our priority list, because it is an extreme set. You're getting it? If you attempt it and you understand what's going on, then this could be an easy doable set. But if you don't get what's happening, then this could be a complete disaster to choose. So an extreme kind of a set, and we know that we are not getting any bay here, which could be both advantageous or disadvantages. We'll have to take the call. So will this be one that you should do definitely now? No, you'll probably put this for later or maybe skip if there are better sets than this. Okay. How about the third set, guys? Have a quick look at the third set. This one's 2 years ago, 23 slot 3. How about this set, folks? Correct, Satyam. That's what I said. Now, out of the 5 questions, you can definitely do 3 if you're comfortable with maps. If you can do just a basic of probability, if you know, you can do the other 2 questions also. So it's a proper extreme situation. It's either too good or too bad. How about this one, folks? How many of you solved this before? Yeah, this one was again a sweetheart of a set. This came in to us in CAT 23, where we saw, which was one of the most difficult, papers we've seen as far as DILR was concerned, right? And but the good thing was there were only 4 sets out of there were only 4 sets with 5 questions each, which was a good thing for us, but also a bad thing because you didn't have another set as an option, right? But anyway, how about this one? A, B, C, D, E, F are 6 police stations in an area connected by streets given below. 4 teams, 1, 2, 3, 4, patrol these streets continuously between 9 and 12. from here itself you know that this is also not a pure map set. This has maps in it as well as what? Maps as well as what? Scheduling. So if you are comfortable with both of these, understanding the maps as well as scheduling, then this is something that you should definitely do. Otherwise, it's better to steer clear from it if you're not at all confident with scheduling. Works for us? Yes. Cool? Done? 4 sets are not a good thing anymore. Difference of opinion here, right? I think we'll end up at agreeing to disagreeing, because I don't think with 5 sets the problem is you need to attempt at least 2 to 3. That puts you in a very tough spot if the third one that you're choosing is not doable under the given time. But with 4 sets, we know that the target is to click 2, get them sorted, then you are able to, and there's no difference in weightage. If each of the 4 sets have 5 questions each, whichever 2 that you choose, you will get 5 questions out of it. But with 22 questions and 5 sets, you had to think about, if I do this, there are only 5 questions here. If I do this, there are 4 questions here. That thought you had to put anyway. So this is maps and scheduling. If you're not comfortable with both, this would be a tricky thing. How about the questions? Visited the largest number of times could be an indefinite question, but I don't think this would give us any trouble if we can make the schedule properly. How many times is definite? Which team patrols at a particular time? How many times? How many times? So what are we looking at? All the questions are doable. Even the first one can be a doable one if we can get the entire schedule. Their timetable, if we can get it. So we are looking for a complete bay. At the same time, we should be comfortable with scheduling. So it's not just a maps question anymore. It has now become a maps based scheduling question. So again, if you are someone who's comfortable with maps as well as scheduling, yes, and we are looking for a complete bay. Is this one better than the second one? Seems like it, because there's not much uncertainty here. And they are again talking about scheduling, which is basically just distribution of time. So it should be a doable. So this is a better set than set 2. But is it a better one than 1? We'll have to take that call when we are solving it. Done? Cool. Well, let's go for the next set now. Set number 4. Cat 17, slot 1. Yeah, Cat 17, slot 1. That's it. Look at the length of the previous set that we saw, the widget one. So lengthy, so much to read, so much to understand. There's only this much. Now you tell me, is this a good thing or a bad thing? Does little data, fewer number of lines, is it a good thing or a bad thing? You tell me, folks. Quick. Vivek Pandey, Bay is just basically our way of showing love to the table. The final data set that you are making, the final table or the final arrangement that you are making, I call it as a bay. Okay. It could be a bad thing because a lot of it is left up to you to understand. Yeah. It could be a good thing that there's not too much to solve, not too much to worry about. So it's a 50-50% thing. It's either a very good thing that there's only little data for you to target, but it could be a bad thing that a lot of it is left up to you to understand. You have to interpret what they are saying. You have to come up with all the possible understandings, cases, all of it. Keep your thoughts a little broad. Narrow thinking could be a trouble here. So both ways, it's weighing 50-50. Let's have a look at the question. Okay, let's just understand this. So new airlines company is planning to start operations in a country. The company has identified 10 different cities which they plan to connect through their network to start with. The flight duration between any pair of cities will be less than 1 hour. The moment you read this, it might look like a scheduling question, right? This might look like a scheduling question because they are saying the flight duration between any 2 cities is less than 1 hour. The moment you get stuck here and you don't read ahead, you will think that, oh, this one is also based on scheduling and I'm not very comfortable with scheduling. But if you read ahead, you will realize that this point has no value at all. To start operations, the company has to decide on a daily schedule. So if you stop here, you will know that this is scheduling. You will think that this is scheduling one and you might panic. But if you read ahead, The underlying principle that they are working on is the following. Any person staying in any of these 10 cities should be able to make a trip to any other city in the morning and should be able to return by evening of the same day. So they're basically saying that if a person is going from A to B in the morning, that same person should be able to return from B to A that very evening. This is basically what they're saying, right? Done? Short baddie way, no okay. Proper shorty, right. The thing is, whenever you get set that have very little data, you can definitely expect the questions to be humongous, and that's what we're seeing here. If the underlying principle is to be satisfied, then they're asking minimum number of flights, indefinite. Suppose blah 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 blah, again minimum number of flights, indefinite. Suppose blah 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 blah, again minimum number of flights, indefinite. Suppose blah 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 blah, maximum reduction, indefinite. So all the 4 questions are indefinite. All the 4 questions are indefinite. That might throw you off because you know that there is no perfect way, and the problem that there's only little bit of data, not too much to work with, could also kind of push you. But we know for a fact that it has nothing to do with scheduling. Do you agree? Do you agree? Does this have anything to do with scheduling? That if a flight starts at 10 a.m. and has to go from A to C, then when should be the next flight planned, like the metro one, right? If a person has to go from A to C to D, then at what time what should be the earliest time that person should reach C so that he can reach D before this time? None of that stuff is given to us. That means it has nothing to do with scheduling. It's all about technically nothing to do with maps also. There's no maps. You're just getting the network between cities. You're just building a network between cities and just finding out the minimum number of direct flights in each of the case. Works? Yeah. So this set again is a make or break kind of a set. If you do it, you have 4 questions in your pocket. If you can't, then you are letting go of all the 4 questions. But even if you attempt any one, if you have the gall or the guts or daring to attend any one question also, you know that you can do the rest of it also, because they're just building on it, right? From the underlying principle, they're just building on the rest of the questions. They're bringing some extensions there with making us understand if they are divided into 4 groups, if they are developed as hubs, so on and so forth. Okay. So how about this set? This one is very similar to the second set. It's again an extreme one. Either make it or break it kind of a thing. It can either help you reach your goal percentile, or it might help you completely throw that goal away and then work on something else, right? So this we will not get any bay per se, because there's no given conditions that there are 10 cities A, B, C, D, nothing like that, right? And it has nothing to do with scheduling. It is a purely network based question where you're just building the network. So make it or break it kind of a situation. So if you are trying to answer this set, you will look at the other sets of the same slot and see if there are other sets that are better than this, then you can take it. Otherwise you got to skip it. Shall we look at the last set? Correct, Dhruv. So this could be one of those sets where even if you were to attempt out of the 4, if you were to attempt 2 of them, you might just get the answer for it. Okay. Okay, let's look at the last set. Are you ready for the last set? Yeah. The last set is here. Again, small packet, big dhamaka, right? That's something that you're expecting of sets that have very little data. So again, it's either a very good thing or a very bad thing, nothing in between there. Here, from the given instructions, right, one map is not given. It clearly is a map based question. They're saying 4 car needs to travel from A to B. 2 routes are available, one via Mamur and other via Nanur. So when we don't have a map, we have to draw the map. They're saying that 4 cars have to go from A to B, but then there's no direct route. They're saying there's one route via Mamur and the other route via Nanur, right? And they are saying that the roads from A to M and from N to B are both short and narrow. A to M and N to B, these are all short and narrow, but nothing given about A, N or MB. In each case, one car takes 6 minutes to cover the distance, and each additional car increases the travel time per car by 3 minutes. So now it not only depends upon the distance or which route you're taking, but it also depends upon number of cars. Yes, so one, we don't have a map. I think we've drawn a decent enough map, but the problem is we need to identify time taken. We have to identify time taken per car. That means we need to know the number of cars in each case, and it gets a little more problematic because they have a condition also. The police department orders each car to take a particular route in such a manner that it is not possible for any car to reduce its travel time by not following the order while the other cars are following the order. That means there could be multiple cases here, that if one car follows this particular route and the other car also follows that route, then what would happen? Or if the other car does not follow that route and takes the other route, what would happen? This one has very high chances of being a breakers kind of a set. Cool? Yeah. All of these are PYQs, Dhruv. All of these are PYQs, okay? If you think this is a doable one, you have to be very, very comfortable with doing trial and error. Yes, because one, we don't know the routes. It could be A and B, A and B. And then if you look at the questions, how many cars would be asked to take the route A and B by the police department? One of the routes, how many cars are possible, they're saying. If all cars follow the police order, what is the difference between the travel time they are asking, A and B, A and B? Till here we've been looking at two routes, A and B, A and B, but now look at it. A new one-way road is built from M to N. Extension, an unnecessary one. Yes. Again here, extension and unnecessary one. That means there is technically no bay as such, but even if you were to work on that, you will have to come up with all the possible cases, right? So they're saying there are 4 cars, right? There are 4 cars, car 1, 2, 3, 4, and there are 2 routes, A and B and A and B. But the problem is you have to come up with what happens when one car is taking this, 3 cars are taking this, 2 cars are taking this, 2 cars are taking this, 3 cars are taking this, 1 car is taking this, all 4 cars are taking this route, none of the cars are taking this route, and 0 here. So basically you're looking at this. So it's either 4 cars here and 0 cars here, what case would happen? 3 cars here, 1 car here, what would happen? 2 cars here, 2 car here, what would happen? 1 car here, 3 car here, what would happen? 0 cars here, 4 cars here, what would happen? Yes, so although the data given to us is very limited, but from that we can come up with so many things that we have to find out. Is this a good news or a bad news? It's a proper bad news. With the questions taking you so long to read, only advantage here is out of the 4 questions, 3 questions are theta. We don't have any more questions. Out of 4, 3 questions are theta. So even if you try to attempt it, and let's say you don't get to a right answer all the time, you can still do a guesstimate, do a calculated guess, and then maybe run away from here. So will this be your first priority set? Probably not. Yeah, based on the complexity, probably not the first priority. Yes, and because it is complex, this one is clearly complex. There is no bay as such. You are just trying out all the possibilities. Yes, 0, 4, 1, 3, 2, 2, 3, 1, 4, 0. All possibilities you are trying. So there will be multiple cases coming out of this. And the questions are also kind of tricky. That means, should you be taking this up on priority? Maybe not. So now you tell me, out of the 5 sets, 1, 2, 3, 4, 5, what will be your priority? Come on. What would be the order in which you will attempt these sets? One, 3, 5, 4, 2, 1, 2, 3, 4, 5, 1, 3 and 2, 1, 3, 5, 4, 2, 1 and 3 can be done in priority. Okay, nice. Perfect. Oh, Aritra is saying 5th one should be your first priority. Ooh. All right. All right. Okay. So done. Now let's see. We will be solving each of these in this order only. Set 1 first, and then 2, and then 3, and then 4, and then 5. and then you will know which one does seem skip worthy when you're doing it. So at least so far, we can say that this one is too complex, right? Too complex here because of the number of cases that you're getting. Yes, this one is definitely complex. That means this is skip worthy. So if you were to choose say 3 sets out of this, fifth one is what I would recommend for you to skip. Because of the complexity and the time running out, you might not be able to come up with all possible cases, especially when after 2 questions they're changing the case. That could be a little tricky for us, okay? Right, Raghav, right. Okay, heavy drivers, let's go. So let's start with the first set. Yes, arrangements based. If you're comfortable with arrangements and you can just understand what this map is saying, this one is a golden set for us. So we've understood what this map is all about. There's nothing to worry about the map. Yes, we know that out of these 12 intersections, we need to find 6 intersections where 6 people are standing and the other 6 that are empty. Yes, and we also need to identify which are those 6 intersections and who are the people waiting or standing at those intersections. Okay, so we have the conditions. We can start off with these conditions and then quickly just place the people here and we are done. Okay, always look at these kind of maps questions and identify the weird one, the awkward one, which could help you understand what should be your first approach. So if you see here, everything else are either horizontal or vertical. The only one route that is diagonal is what? This route. Yes, since this is the weird thing given to us, this is a different thing given to us, this could be beneficial for us. Yeah, this point B, G, G, B, this could be a little bit helpful for us maybe when we go ahead. So always identify the weird ones and then see if you can target those. Cool? Let's go. So let's start this. So we understood what they're saying, right? Anyone who's standing at this point can see this person can see this person, can see this person, can see this person, like that. Okay. Cool. Shall we begin then? All right. So, okay, a couple of things that were told to us was what? No 2 people are standing at the same intersection, which is good for us. Okay. So, no more than one person cannot stand at an intersection, which is good for us. Okay, let's go. So, now they are telling us that X, U and Z are standing at 3 corners of a triangle formed by 3 street segments. Like I said, the only place where you can form a triangle is where? This zone. Yes. So we know for a fact that out of these 3 people, X, U and Z, one of them should definitely be standing here, the other person should definitely be standing here, and the third guy could be either here or here depending upon which side the triangle is facing. Works? So it's either this or this. So it's either BCG or BFG for X, U and Z, which is a very good starting point for us. But the problem here is, if you look at only this condition, if you look at only the first condition, imagine the kind of cases you can come up with. Yeah, you can come up with this being X, this being U, X, U and Z, right? This being Z. Yeah, 3 people, 3 places, that's 6 cases, correct? X, U, Z, X, Z, U, U, X, Z, U, Z, X, ZXU. So I will get 6 cases, and because there are 2 triangles, I'll end up getting 12 cases. Do you think this is a very good idea for me to just start off like that? No. So one thing I am clear of, that B is definitely occupied by someone, G is definitely occupied by someone. Between C and F, one of them is occupied by one of the X, U, Z, right? That thing I know, I can keep that in mind. But if I work only on that, I'll end up having 12 cases. Do you think I'll be in the situation, in a condition to do that? Definitely not. So let's read ahead. Now they are saying that X can see only U and Z. See, X can see only, not can see U and Z, only U and Z. That means X cannot see anyone else. So for example, if X is standing here and U is here and Z is here, that tells us what? If X is here, for example, then this, no one is standing here, no one could be standing here, no one could be standing here also. So this kind of tells us that in the vicinity of X, right, in the vision, the straight line of X, these 3 places will definitely be empty if X is standing here, for example. or here. X, if X is here, then this also is gone, this also is gone, this also is gone. Like that you can work on this, okay. So this could be our second thing that helps us, that X in its straight line has only U and Z there, no other person, okay. Y can see only U and W. U is the common point here. Can you see this? U is the common point between these three conditions. So the moment you identify where U is, the moment you can place U, you can then place X and Z, and you can place Y also and W also, because Y can see only U and W. Continuing with the flow of U, started with U, here also there is U. They're saying U sees V standing in the next intersection behind Z. So U can see V, but V is standing behind Z. That means what? These three people, U, Z, V, should be in a straight line, correct? U, Z, V should be in a straight line, either like this or like this, correct? Yeah. So U sees V standing in the next intersection behind Z. Both ways are possible. Now this can be a very good one for us to start with, because now with U, there's so many things revolving around U, with which we can reduce the number of cases. Works? Yes. W cannot see V or Z. We can use this later because V and Z are here. So W cannot be here or here. Getting this? W is not in the straight line as U, Z and V, because if the person can see, if W can see V and Z, that person can definitely see U if they are in the straight line. That means they are not. And none among the 6 is standing at intersection D. So there's no one standing here. There's no one standing here. Now we can start working with this. Combine this with that and then see where it takes us. Ready? So can we start off by placing U at different places and see what happens? Are you ready? So if I were to place U, for example, here, right? If I were to place U, for example, here, then I should have one person here, correct? So I would have, let's say, X here and Z here. But can that happen? Can U and Z be like this, diagonal to each other? No, because U, Z and then V should come, but there is no diagonal here. So we know that U cannot be here. That means U should be here, Z should be here, or Z should be here, U should be here. So far good? So far good? That means only one thing, that X has to be here. Works? That's a good news for us, right? X has to be here because U and Z should be in a straight line. So if they are in a straight line like this, also could work, right? U here, Z here, V here, this could work. But that would mean X is here. That would mean X is here. So we might have one more case to build with. Yes, we might have one more case to build with, that if X is here, then U or Z is here. Yes, and it has to be U, Z and V. So U has to be here, Z has to be here, V has to be here. But what's the thing? They're saying that X can see only U and Z. So X can see U, X can see Z. In the blue case, X cannot see this, X cannot see this, X cannot see this, X cannot see this. If at all we go with the blue case, that is, right? Make sense for us? So far good? Let's continue with the blue case and see if that's a useless one for us, because once we identify where X is. So next they are saying that, so we have done placing U, Z and V. This is X for us, and X cannot see these spots. So how many spots are left now? We have placed 1, 2, 3, 4, and we need 2 more. Do we have 2 more? Yeah, we have 2 more, which we can kind of make use of it later. Okay. Next, they are saying that W cannot see V or Z. If W cannot see V or Z, that means W cannot be anywhere in this line, which is helpful for us because any which ways this line is full. Any which ways this line is full. So this could be a useful thing for us. Next, so W cannot see V or Z. That means W cannot be here. W cannot be here. The only place where W can be is this spot, correct? W cannot see V or Z. W cannot come anywhere then. W cannot come anywhere. For Z, if Z is here, W cannot be here or here. And there are no empty slots here. If V is here, so W cannot come at all. Will it work? Where will W come then? For Z, W cannot come here. Here W cannot come here. Here already U is there any which ways. And then W cannot come anywhere here. If V is here, W cannot come here also. There is no place for W. That means the blue case itself is completely incorrect. We can let go of the blue case and then we are sure that X should be here. Done? X is definitely here. One of U or Z is here. Works for us? So at least we were able to place X. Now that we know where X is placed, I know for a fact that X cannot see anyone except for U and Z. That means this spot is empty. This spot is empty. X cannot see anyone here. X cannot see anyone there also. This spot is also empty. Yeah. So 1, 2, 3, 4 spots are gotten rid of. 1, 2, 3 we have placed. Now we have to place V. Right? We have to place V. U and so we have to do U, Z, V. So if this is U, this is Z, this will be V. If this is U, this is Z, this will be V. So V could be either here or here. V could be either here or V could be here. We can start with one of the cases and see where it takes us. Again, blue case, okay. So if U is here, this has to be U, this has to be Z. U, Z, V. Works? Again, the thing that can make a difference for us is what? Where we are placing Y and where we can place W. Okay. So now let's look at W. Can W come here? No. Can W cannot see V or Z. So W cannot come here. That means W will be here. Yes, the only place where W can come is here. Yes. And once we are done placing W, what are they saying? Y can see only U and W. U is here, W is here. The only place where Y can come is where? Here. But what's the problem? Now Y can also see Z and V. Is it helpful for us? Y can see U and W works, but he can see Z and V also. That cannot work, which means our blue case is wrong again, which tells us what? V cannot be here. So now I know for a fact that V has to be here. So this is our V. Yes, this is our V. If V is here, then this should be Z. This should be U. Works for us? Perfect, guys. So V, Z, U is done. X is done. Now we can start working on the others. They're saying W cannot see V or Z. W cannot come here. W cannot come here. W cannot come here. The only place where W can come is here. W cannot come anywhere in U's line. Right? Cannot come anywhere in V's line, cannot come anywhere in Z's line. So W can be here or here also because he can see U. Okay, but we'll look at that. Y can see only U and W. Only U and W Y can see. That means Y has to be here, only U and W. If, for example, if W was here, if Y is here, Y can see V also, not allowed. If Y is here, Y cannot see U because U is diagonal. So the only possibility is this has to be Y, this has to be W. We are done. Like I said, this is hardly a maps based question. It's purely an arrangement based. Are we done placing all 6 people? 1, 5, 6, 1, 4, 6, perfectly done. You can, if you want, you can quickly go through all the conditions and check if this makes sense for us. Okay. So X, V, Z, U, Y and W. Khatam. Done. Yeah. This will only work for you, will only be helpful for you if you are comfortable with arrangements where you are getting multiple trial and error. If you are someone who cannot work through trial and error, difficult. Done. So for people who don't understand trial or error and people who don't get arrangements, this one should not be on your first priority. Okay. So now that we are done, we have everything correct. X, V, Z, U, Y and W. Perfect. We can jump to the questions, answer questions, check in, cash out, run away. Okay. Go for it. Right, Iram. Definitely. Like I said, trial and error, arrangements, mandatory. Who is standing at A? Good thing for us, no one is standing at A. This question we could have answered here itself. When we figured out that X has to be here, that means nobody can be at A or this or this. That means we could have easily answered this one. No one is standing at A. A is empty. Done? Someone said D. Iram, V is not standing at A. V is standing at E, not at A. Who's standing at A? They are asking. At A, no one is standing. Done? Cool? Yeah. Tejal, I'm not saying it's difficult. I'm not saying it's difficult. I'm saying it's a doable set if you're comfortable with arrangements and trial and error. That's it. Done? Right, Ishika. Who can we see? We can see who? We can see Z. We can see U. We, nothing here, nothing here, nothing here. We can only see Z and U, no one else. U and Z only. We cannot see W. We cannot see W because W is here. Yeah. W cannot see V. If W cannot see V, then V also cannot see W. That means this option you can eliminate, kind of a brownie. Now between option B, C and D, then you will have to take a call. Yeah. Only thing is, this says U only, this says Z only, this says both. So it has to be at least one of U or Z. That way you can, zero down on the answer. Again, it's a luck thing if you're not solving it completely. What's the minimum number of street segments that X must cross to reach Y? X should reach Y. And we have to reduce the number of street segments or intersections. Yes. So if I have to reach Y, I can always take the straight route. 1, 2, 3. So I'm crossing 3 intersections, right? 1, 2, 3. Yes. But I need to reduce it as much as possible. So for me to reach from B to Z, or even if I go like this, is the same. 1, 2, 3. But I can reduce from lane 1 to lane 2, I can reduce the number of steps by going like this. So if I were to take this route, 1, 2, I can directly reach here. Yes, so what is the minimum number of street segments? 2 street segments. Done? Mind you, street segments, not intersections. Street segments. This is one street. This is one street. Total 2 streets. Got it? If you're looking like this or like this, this is one street, this is one street, this is one street. 3 streets either which way. Clear? Be very careful. 1 is the number of intersections. They are not asking number of intersections. They are talking about street segments, not intersections. Be very careful. Had they asked for intersections, then you would select 1. Okay, this would be a trap if you don't read the question carefully. Done? Cool, everybody? Perfecto. Next, last. Should a new person stand at D? So they're basically not even complicating it. They're saying, we said that there's nobody at D. If someone stands at D, let's say one more person, somebody P is standing here, for example, they're simply asking, who among the 6 would she see? How many people can see P is what they're asking. That means if P can see them, they can see P. So we just have to see how many people P can see. P can see 1. P cannot see anywhere here. P can see here also 2. So there are only 2 people P can see, X and W. U and Z, no. P and X, no. U and W, no. Done? Perfect. So like I said, this set, if you are comfortable with arrangements and doing a bunch of trial and error, this one is definitely a doable set for you. Okay. Otherwise, you just skip ahead. That's it. So the amount of panic, the amount of stress that we took for the previous set, right? After doing that set, this set might not be the best thing. If at all both of them come in the same slot for you, after doing the set 1, set 2 should not be the one that you should choose. But anyway, we'll solve it now. Feeling hungry, Aditya? Same here, buddy. Only difference is your hunger is for something else, my hunger is for something else. But anyway, let's go. Satyam, you want to do these questions on your own? That might take us a lot of time, man. We'll do this, no? If you're hungry, maybe on the side, just eat a little bit. We'll just finish this off. Okay, we'll not do 5 sets. Okay, I understand Sunday afternoon probably planning a heavy lunch and taking a nap, or resting for the rest of the week that you worked hard so much. So we will end up 4 sessions. Okay, or maybe 3 sets. Let's do. So we've read this. Okay. We'll read this part now. Every day the supplier gets the information about the demand values of the 4 locations and creates the travel route that starts from the warehouse. Starting is warehouse and ends at a location after visiting all locations exactly once. Visiting all the locations exactly once. So he is allowed to go from the workshop, and this person has to visit all the other location but can visit only once. While making the route plan, the supplier goes to the locations in decreasing order of demand. This is the key point here. Most important point of this set is the supplier goes to the locations in decreasing order of demand. So the choice of which location to go first and which location to go last, so on and so forth, would depend upon these values. Yes, wherever the demand is high, that's where he will go first. Wherever the demand is low is where he will go last. Clear? Yes. If there is a tie for the choice of the next location, let's say if there are 2 locations having the same demand. For example, let's say this is 70, this is also 70. Yeah, this is 70, this is also 70. Now there is a tie, correct? Because both 70 are at the same level. The supplier will go to the location closest to the current location. That means this is where distance will pitch in. Whichever is closest is where. So for example, if that person is at the warehouse, then 5 kilometer is closer than 12 kilometers. That means he will choose A first and then C. But like I said, it depends upon where he is. If that person is at B, and has to choose between A and C, what would happen? This is 4 kilometers, this is 6 kilometers. So he will choose C first and then A. Got it? So distance will pitch in when there is a tie. Also, while creating the route, the supplier can either follow the direct path if available from one location to another, or can take the path via the warehouse. What they're saying is, this person will always prioritize direct route, if there is. So for example, if this person has to go from B to A, he will choose B to A route, the direct route first, or then pass through the warehouse. Yes, or then pass through the warehouse. Okay. But what are they saying? What are they saying? The priority is what again? He will have to reduce the distance. Correct? He will have to reduce the distance. If both paths are available, direct and via the warehouse, the supplier will choose the path with minimum distance. Yes. So if I have to go from B to A, is 6 kilometer minimum, or B to W, W to A, 10 and 5, 15 kilometer better. Which is closer, 6 kilometers or 15 kilometers? 6 kilometers is closer. Got it? So all of this instruction, we can't make anything. We can't make a bay, we can't do any pre-work here, but just understand the conditions, that's it. There are too many to handle at that stage. Okay. So what are the priorities? Number 1, decreasing order of the demand. Number 2, will try to take the closest route possible. Number 3, can go through warehouse multiple times but cannot go through any other cities or any other location. So for example, if this person has to go from B to D, okay, if this person has to go from B to D, can he take a direct route? There is no direct route. That means he will have to go from B, C, D is allowed? No. If he has to go from B to D, then either there should be a direct route BD, which is not there. Direct route BD is not there. That means the only option for him would be to go from B to warehouse to D. That means this person can visit warehouse multiple times. Got it? This person can visit the warehouse multiple times, that's allowed. But no other location can be visited more than once. Got it? Yeah. With all this in mind, now we have to do a bunch of hypothetical questions, which could be a little tricky. But once you understand what the priority is, that's way more than enough. So we'll start off with the first question. Shall we start? The first question has nothing to do with probability, so we'll just jump into it. if the last location visited is Ahmednagar. Yeah, out of the 4 locations, 1, 2, 3, fourth location is Ahmednagar. Yes, we know that they are always arranged in decreasing order of the demand. That means Ahmednagar should have the minimum possible demand. Got it? Ahmednagar must have the minimum possible demand. They are asking what is the total distance covered in the route. This indirectly is an indefinite question also, because we know that he will choose the minimum distance route, right? The route that has least distance is what his choice would be. Okay, so indirectly they are also asking what is the minimum distance. Clear? So Ahmednagar, if it's last, think about this. If Ahmednagar is last, can Ahmednagar have 70 as the demand? Because if Ahmednagar is 70, 70 is greater than 40 or 60. That means after 70, only 40 or 60 will come. Getting this? After 70, only 40 or 60 will come. So can Ahmednagar have 70 as the demand? Not possible. Because if after A, B comes, then this condition is not met. Clear? This condition says Ahmednagar has to be the last one. So it is clear that Ahmednagar will have 50 as the demand. Got it? Ahmednagar will have 50 as the demand. Done? Clear, everybody? Done? Perfect. So now we have to arrange, we have to identify the other people's demand based on this 50. So if this number is 50, can this number be 40? No, right? Because B has to come before A. That means B has to have a higher value than A. It can't be 40. If 40 comes, he will be here. B will be here, not allowed. That means this should be 60. Yes, B should be 60. How about D? Can D be 30? Again, not possible. D can't be 30. Why? Because if 30 is lesser than this, that means D will come here, which is not allowed. So D also has to be 50. C could be 70 or 100, we don't care. C could be 70 or 100, we don't care. C has to be the maximum, irrespective of it. So what will be the priority? First, this person will have to visit C, could be 70 or 100, doesn't really matter. Then after this, after 100 or 70, whatever, then it should be 60. Next number, which is B. Then it should be 50, which is D. Got it? So this should be the priority. This is not the route though. This is not the route. He can't go W to C and then go B, A, D, not allowed. Not like that. Yes? Because this person cannot go from one place to another unless and until there's a direct route or going through the warehouse. And see, from W to C can go, from C to B can go, but from B to D, this person has to go via the warehouse. So we'll also have to check the distance now. Ready? So first thing, identify the priority we have done. So we'll start off with the route. I can go from warehouse to C directly. Warehouse to C, 12. From C, I have to go to B. Which is better? Direct route is better or going through the warehouse is better? Direct route is just 4 kilometers. Through warehouse, it is 22 kilometers. 12 plus 10. Direct is better. Yeah. So from C, he will directly go to B, 4 kilometers. So far, okay? Yeah. From B, he has to go to D now. From B, he has to go to D. Has to be only this route because he cannot go to C again. Not allowed, right? So B, W, D. So B to W is 10. W to D is 2. Now D to A, tell me which route, guys, you tell me. Now I have to go to A, correct? Now I have to go to A. You tell me D to A, which route is feasible? Will he take D to A direct? Will he take D to A direct? Or is it better to go from D to W then to A? Which is better? Through the warehouse is better because if he goes D to A directly, it's 8 kilometers. But if he goes from D to warehouse and then to A, it is 2 plus 5, 7 only. So this is a better choice. From D, he will go back to the warehouse and then go to A, which is 2 kilometers and 5 kilometers. Done? Perfect. Very good. Now just add this up. They're asking for the total distance. We can do this. 16, 26, 28, 30, 35 kilometers. That should be our answer. Cool, guys. Any doubts you have? 35. Perfect. Very good. Yeah, very good. Nice. Great job, guys. So technically, if we look at the set, right, is this easier than the first one or is it more difficult than the first one? Completely depends upon what you are more comfortable with. If you are comfortable with arrangements and trial and error, set 1 will be better. If you are comfortable with trying out different cases on the go, not doing any bay, not making any pre-work, then this would be better. But the only thing is too many things to keep in mind here. Okay. Try the second one. If the total number of widgets delivered in a day is 250, now what they're doing is they're not telling us which is the first or the last location, but they are giving us the total number of widgets. Yeah, like in this case, the total number of widgets could have been 50, 100, 160. It could either be 260 or it could have been 130, correct? 230. So if this is 100, 160, 110, 260, or it could have been 130, 180, 230. Either 260 or 230. So what they are giving us now is, they are giving us this value, that the total widgets is this. Now we have to identify what would be the total distance. That means we don't know which is the first location or the last location or the order of the location. And we have to minimize the distance and find out the total distance. Clear? Yes. So now in this case, again, we would have to start it off like a puzzle question, like a number based puzzle question, where they're saying sum of the 4 numbers is 250, 260, 230, 260, very close, 250 we can maybe come to, but we'll see. So we'll first do the trial and error, identify what should be the total. Okay. So I have A, B, C and D. Yes. Only thing I know is the total is 250. Now let's see what we can identify, right? The priority, if we can identify, if we know the priority, which location is when, first, second, third, fourth, then we can come up with the route also. Yeah. So here the best way to do is start off with a big number and then compare the rest of it and see if it works otherwise. So this is a very good spot for us to start. If I say C is 100, if I say C is 100, then I should get what? A, B and D as 150. A, B, D as 150. I'll see if I can manage 150 or not. Yes. So after this, I can, play around with this. Let's say if I say A is 70. If I say A is 70, 170 is done. I need 80 here. Can I get 80 here? I have 30, 40, 70, 30, 60, 90, won't work. I have 50, 40, 90, 50, 60, 110. I don't have an 80 at all. I either have a 70 or a 90 or a 110. I can never match 250 if this number is 70. Maybe I'll try making this as 50. What if this number was 50? So if this is 150, then I need B plus D as 100. Can I get 100? We've already seen total possibles are either 70, 90 or 110. 100 is not allowed at all. That means what is wrong? Us assuming that this would be 100 is wrong. This can't be 100. This has got to be a 70. Works. So C is got to be a 70. Now the aim is to get 180 out of the 3, which I think I can get. How? Just by looking at the minimum. If I go 50, 90, how much is it? 50, 90, I need how much? 180. Yeah, 90 and 90 won't work for me, but I can do maximum. I can go 70 plus 60, 130 plus 50, 180, perfect for me. So A is got to be 70 again, B is got to be 60, D is got to be 50. Yeah, 130, 200, 250, perfect. 70, 60, 70, 50, done. Yeah. This puts us in a trouble. This is not a very good number. Why? Because now I have A is also 70, C is also 70. Yeah, A is also 70, C is also 70. But what do I know? We will always choose the one that is closest. Yes, we will always choose the one that is closest. Makes sense for us? Yeah. So which is closest from W? Which is closest from W? Is it A 5 kilometers or C 12 kilometers? Which is closest? A is the closest. Yes. So we'll go for that then. Yeah. So the order should be what? A, then C, then I should do B and then D. This is the order A, C, B, D. So this won't be the distances. Huh? Distance we still have to work. Distance we still have to work, but I know that it is A, C, B, D. Can we start working on the distance now? So I know it has to be W to A. W to A is 5. A to C I can't go directly, so I have to go through W again. So A to W again 5. W to C 12. From C I need to go to B. Is direct better or going through the warehouse? Direct is better, just 4. From B I need to go to D. Obviously there is no direct route, so 10 and 2. W and then D. Perfect? Works. So how much is it? 10, 22, 26, 36, 38. Aritra is saying 29, buddy. 29 is not the answer. 38 is the answer. Please check your calculation. Aksh, definitely lengthy, but all the time that we spent in understanding this, everything that we've spent in understanding this is what would take you long time. With each of the questions, then you can spend the apt amount of time. But yeah, there is a lot of trial and error involved. A lot of puzzle based solving is also involved. Be very careful. Done, guys? If you want, you can also try the other route, which is first C, then A, then B, D. That also you can try. That distance will definitely be more than 38. So that is gone. Okay. Third question. What is the chance? So now is where probability comes into play. This is where probability comes into play. So now you also have to look at the percentage bit. So if you're not comfortable with probability, you might want to rethink this one. Okay, let's see. So what is the chance that the total number of visits delivered in a day is 260 and the route ends at Bikrampur? If you are someone who does a lot of shabby work, rough work that you are doing, if you do it ineligible, not illegible, if you write things that you can't revisit and check what is this, what kind of a doctor has written this prescription, if you are that kind of a person, then this would be a little troublesome for you. But if you are someone who can maintain decent, not neat, you don't have to use glitter pen, you don't have to use ribbons, you don't have to decorate it, but if you can maintain a neat one. Have we done 260 before? We have done 260 before. We have done 260 before. But what's the problem? With 260, it's not ending at Bikrampur, it's ending at A. Not very helpful. Got it? Yeah. It is 260 which helps us, but it's not ending at Bikrampur, it's ending at A. We want something that ends with B. We want something that ends with B, but also has 260 units. Yeah. So now if something is ending at B, I need 3 more on top of it. That means the demands must be higher, and then I can find out the probability also. Got it? So this would be the location, this would be the demand, and this would be the probability. Okay. So they're saying B should be the least. B should be the least. Out of 40 or 60, tell me, out of 40 or 60, can B be 60? What happens if B is 60? D is 50 is less than 60, 30 is also less than 60. That means D will become last. Is it possible? No. So this has got to be 40. This has got to be 40 with how much probability? 30% probability. Okay. That means everything else should be greater than 40. Are you getting this? Everything else should be greater than 40. That's all we care about. 30 is greater than 40? No, it is not. It should be 50. So whatever is the previous one doesn't really matter for us, because distance they are not asking. Are they caring about the distance? No. Does distance depend upon the priority? No. Probability depends upon the priority. So we don't care about the distance. If B should be the last, this should be greater than that, which is 40. So if I were to place D here also, D's demand is 50, chances are 60%. Yes. So now I'm looking for anything in that range, it's okay. Anything greater than 40, I'm okay with it. Anything greater than 40, I'm okay with it. But now tell me, if this is 50, this could be 50 or 70, doesn't matter. This could be 70 or 100, doesn't matter. But we have to end at B. Yes, we have to end at B. So now tell me, what else can you try here, guys? What else can you try? Sir, I have a problem regarding mocks. What problem, Sukun? What's your problem, beta? What problem? So I know that the total should be 260. I know that the total should be 260. Yes. Out of 260, 90 already done. That means I'm looking for 170 more. From A and C. 170, how can I get? 100 and 70 only possibility done. So C is 100 with 70% chance and A is 70 with 60% chance. 170, 220, 260, perfectly done. Works? So from the outside, this might look like a very complicated thing, but the moment you finalize B, from B once you finalize D, then it's just a matter of checking the total. That's it. So now probability. Probability, always remember, whenever you have to use AND, does this person have to visit C? Yes. Does he have to visit A? Yes. Does he have to visit D? Yes. Does he have to visit B? Yes. So he's supposed to visit all the four. It's not OR. He can either visit C or A. That is when OR comes into play. So otherwise it's AND. And whenever there is AND, you always multiply them. Whenever there is OR, that he can visit either this or this, he can visit either this or this, either this or this, that's when you use plus. So since here the situation is AND, I just have to multiply this. So for this I'll need my calculator. I simply have to do 70% is 0.7. So 0.7 into 0.6 into, I'll just use the calculator. Let's go. Quickly bring up the calculator. I have to do what? 70% is 0.7 and 60% is 0.6 and 0.6 and 0.3. I'm getting 0.00756. This is in terms of decimal. I need in percentage into 100. It's 7.56%. So the probability is 7.56%, which is done. Cool. I'm not able to read set completely. I mean, I miss important minute details. I know this is happening and I stay alert till it's repeated. Sukun, the problem could be that you're looking at the timer and you're panicking. You need to calm your nerves. It's very, very important that the moment you enter the DILR section, you have to take a very, very long breath. Yes, take the longest breath that you've taken. Calm yourselves. Your aim is not to cover all the 4 or 5 sets. Your aim is to cover only 2 or maybe 3. Keep that in mind. Read as if your entire life depends on it. If you miss out minute details which can throw you off completely, a small word like only, a small negative word like no, not, cannot, this can completely change the meaning of a sentence or a condition. Yes. So take the longest breath, calm yourself down, relax, tell yourselves that your aim is just to answer this set at this moment. You should not have anything else going on in your mind. That's when you will be able to focus completely. Okay? Works? Cool, guys. Shall we move on? Next question. Let's go. Fourth question. This one also has something to do with probability. But this time what they're saying is, if the first location was Ahmednagar. Ahmednagar is the first location. Ahmednagar is the first location. Yes, that means everything else will follow Ahmednagar. So either 70 or 50 will see that. Then what is the chance that the total distance covered is 40 kilometers? This is another troublesome thing for us, because if we have to place our probability based on the distance, so we will have to do some trial error here to understand. But one thing we know is, if Ahmednagar is the first ever position, first ever, can it be 50? No. Why? Because if it is 50, both of these numbers are greater than 50. That means C will come off before. Not possible. This has to be 70 with 60% chance. This has to be 70 with 60% chance. If this is 70, this is also got to be 70 because this can't be 100. Then C will come before. This is also 70 with a 30% chance. Okay. Beyond this, we'll have to figure out between B and D. Yeah. Both of these numbers are lesser than 70. Less than 70, less than 70, less than 70, less than 70. So B, D, we will have to do some trial error here. So it's A, C for sure. Yeah. Till A, C we are clear. Till A, C we are clear. Now we either go D first and then B, or we go B first and then D. That would depend upon what? The distance being 40 kilometers. Yes, so here it's not about minimum distance between ACDB, ACBD, which is minimum, no. Which gives us a 40 kilometer distance is what we have to see. Understood? So we'll have to do both. We'll have to try both. Yes. First B and then D. First D and then B. Both we have to try. So I'll try it here. First case, I'll go A, C, B and then D. Check the distance, how much we are getting. The second case, we'll go A, C, D and then B. See how much distance we are getting. Okay. So let's go. Warehouse to A is 5. A to C. Have we done one of this before? Not in the direct way, but indirectly we have done this. Why do I remember doing A, C, B, D or something? A, C, B, D we have already done. A, C, B, D we've already done. See, if you have a good amount, good, neat, legible work on your rough sheet, you can always come back to it, reduce the amount of time. We've already done A, C, B, D. How much is A, C, B, D? It's 38, not 40. I don't have to do this again. I know this is 38. From which question is this? From second question. I don't have to do this. So I know it has to be this only. A, C, D, B only. Yeah. If you're still a little shaky that what if this is wrong, what if I've understood this wrong, what if I've done some mistake, then maybe write down the entire distance and find out the total. But I know that it has to be A, C, D and then B. Yes. So D should be greater than B. D should be greater than B. We know that D is got to be 50 because 30 is lesser than both of them. This has got to be 50 with a 60% chance. And B has to be lesser than 50, can't be 60, it has to be 40 with a 30% chance. So how much is this? 6 into 3, 18, 6 into 3, 18, 18 square is 324, so the number should be 324. Where do I see 324? Only here, this has to be. Yeah, if you are comfortable with multiplication and squares, you can directly get there. Cool? But anyway, we just use the calculator just to be sure of it. 0.6 into 0.3 into 0.6 into 0.3 is 0.324 into 100 is 3.24, which is golden. Okay. If you are not very confident with this, then only you will sit and make the root. Okay, we'll make the root if you want. So we go W to A, which is 5. Then A to C directly not possible. So A to W again 5. W to C is 12. From C I need to go to D. This is 6. This is 14. 6 is better. Directly go to D. From D I have to go to B. Has to go through the warehouse. So 2 and then 10. Check. 10, 22, 28, 30, 40 kilometers. Perfect. Do this only if you are not sure about both the cases, and you don't have to take so much time with ACBD because we already have that. Okay. So if you know how to recycle, reuse your work, you can save a lot of time, but you have to have an organized way. For example, if you are solving question 1 here, okay, and in between that itself somewhere here you are doing question 2, here you are doing question 3, all full khichdi you made. And from the khichdi now they are telling that remove the rice separately, remove the dal separately, you can't. Okay, so otherwise khichdi is a very good food, but it should not be in your rough note, okay, rough sheet. Cool. Perfect. The fourth question is also done, 3.24%. Let's go to the last one. If Ahmednagar is not the first location, With positive conditions itself, it's very shaky. With positive conditions itself, we are panicking a little. Negative condition, we don't know. So A cannot be the first one, but it can be the second, can be the third, can be the fourth, we don't know. And the total route distance is 29 kilometers, they're saying. Then which of the following is a possible number of widgets delivered on that day? Again, possible number. That means we could get multiple cases. We could get multiple cases and we'll have to try that. Okay, got it? Cool. Moderate level with 4 or extreme set with 6 questions. Buddha, it again depends upon your confidence level. If you're confident that you can do the extreme one with 6 questions and get even 4 or 5 out of them right, then that's a good thing. But if you think doing the extreme one will eat up a lot of your time and energy and still there are less chances of getting more than 3 or 4 right, then the moderate one is always a better choice. Okay. Sir, how to erase pen written cases where multiple case we are doing? Mauryan Empire, I don't think that's possible. You won't get a pen eraser. You will not get any kind of eraser. In fact, you will not get a whitener, nothing. Best choice there, either make the table or whatever big enough so that you can strike it off and do the next one, or draw another table, get it out of the way. Okay, let's go. So Ahmednagar should not be the last one. That means Ahmed cannot be the first one. That means Ahmednagar can be the second, can be the third, can be the fourth priority. But the distance is 29. Have we seen 29 anywhere before? Quickly check. We've seen 38, we've seen 40. Have we seen 29 here? I don't know. We're not sure if we've seen 29 here because we did not calculate the distance. Is it 29 here? No, 38. This is also 35. This could be a place where it could be 29. We don't know that. But if we were to try this, we might as well try the whole thing, right? Chalo. Anyway, so if Ahmednagar is not the first, between 50 and 70, this could be anything. But this cannot be 70. Getting this? If this is 70 and this is 70, then what would happen? If this is also 70, this is also 70, then what would happen? But I think if this is 70 and this is 50, this could also work, right? So we don't know about A. Both being 70, 70 may work for us, may not work for us, right? Because if both are 70, then it would depend upon the distance, yeah? And distance is fixed at 29. That means A should be at a 50. C could be anything. And if this is at a 50, then we can have anything here and here, because once C comes ahead of A, that's all we want. A should not be the first one is all that they're saying. Everything else we'll have to figure out. Yeah. Let's see. So one thing we know is C should be ahead. C should be ahead with either 100 or 70, doesn't matter. And then maybe we can have an A, we don't know, with 50. If this is 50, then this would be 40. If this is 50, this would be 40, right? Or it could be 60 also, because if A we are fixing at second place, that is, if A, okay, distance matters here, right? We have to reduce the distance, massively reduce the distance. From 40 and 38, we have to bring it down to 29. 9 kilometers we have to reduce, right? 9 kilometers we have to reduce. So I think we have to work on the distance here rather than. So if I go from C to A, I have to do 12, 12 and 5. 29 kilometers here itself is over. Can you see this? 12, 12, 24 plus 5, 29 here itself is done. So I know second cannot be A. Second one cannot be A. So from C we either go to B or then to D. We can figure that out. Either B or D. Let's say if we fix at B, from B we can do A and then D. That could work. This is 6 and 8, 14. From B, if we do 10 and, B we do D and then A, that's 12 plus 8, 20. 14 is easier than 20, I think. So maybe we can do A first and then D. Yeah, we have to reduce the distance. We can do A first and then D. So if this is the order, B has to be greater than 50. That means B has to be 60. This has to be 50. And D should be at the end. So it could be 50 or 30, anything works. It could be either 50 or 30, anything works. We'll just quickly check the distance once, okay? So we got W to C, which is 12 kilometers. Then C to B, we can go directly 4 kilometers. That's 16 kilometers. I need 13 more. Let's see. I can do 13. I can go like this and then come here and then come here. 6 plus 7, 13 works perfect for us. So from B, I can go to A directly with 6 kilometers. From A, I'll go to the warehouse again and then go to D, making it 29. 16, 22, 29 kilometers, perfect. Yeah, so I found out the route. This would be the total, perfectly matches. But possibilities, right? So possibilities, this is 110. 110 plus either 150, 110 plus 150 could be 260, or 110 plus 120 could be 220, or 110 plus 140 could be 250, or 110 plus 100 could be 210. 4 possibilities are there. I'll just check with the options. 210 is possible, 200 is not possible, 250, I think something is wrong here. 110 plus 120 is 220, 240, not 250, 240. So 250 is also not there. 220, again, why is 220 there? 110 plus 100 is 210. 220, I don't think is possible. We're doing a little bit of mistake with the addition, yeah. So 110, okay, 110 दिमाग में रख लो, keep the 110 in your mind. 150 is 260, 140, 130 is 240, 230, not 220, sorry. This could happen if your brain is worked out a little. At this stage, I know our brains are worked out completely. So this could happen. If in that case, you can maybe write it down if you want, okay? Write it down, I think it's better than to do it with hands and mentally. Anyway, these are the 4 possibilities, out of which only 210 is available in the options. Done? Babe, yeah, this one has a lot of trial and error. Entire set, in fact, has a lot of trial and error. But yeah. Out of 5 questions, even if you can salvage 4, the 5th one, maybe you can skip it, or if you think it's taking you longer than the rest of it, just jump to another set. You can take that call at that moment. Okay? Done? Oof. So I think it was a good choice for us not to keep it on the priority, right? Putting the second set, maybe the 3rd or the 4th or even the 5th for you could be a good choice here. Yeah, the second set should not be the first one that you attempt. Okay, we'll do one more set and then wrap it up. Shall we do that? Ved, yeah. You can take a call based on how much time you have left and how many sets you've attempted. If this is your last set to attempt and you don't have enough time to start a new one, then maybe you can skip it, Ved, okay? Aksh, that's a very common problem and I think that normally happens. What we are doing is we are trying to run a sprint. Yeah. So imagine that your race track is 300 meters long. Okay. It's 300 meters long and it's split as 100 meters each. Okay. What beginners, what novice amateur players, amateur runners do is they go with maximum energy here. When they go with maximum energy, at least half of their energy is gone there. Getting this? More than half of their energy is gone there. If you lose out on 50% of your energy, yes, Then when you enter DILR, which takes up a lot of your space here and here, DILR, VRC will take up space here, very little here. DILR takes up both the spaces, right? So despite trying to reduce as much energy as possible, even if you bring your energy down to 30%, what happens is 80% of your energy is gone. With a section like quant, 20% you'll slowly slow down. You'll definitely not be able to clear the race at all. Because what we think is we are running a sprint. It's not a sprint, it's a marathon. Getting this? You should not be thinking about a sprint, it should be a marathon. That means if I am giving 33% energy here, I should be giving 33% energy here, and I should be giving 33% energy here. Every single leg of this marathon should have equal stamina, equal energy. How can you get that? By practicing. Give as many mocks as possible where you try to calm yourselves during VRC. You should not spend your entire energy there. The moment you realize that your 30%, 33% is gone, slow down, relax, take a breather. Because this is where a lot of your energy gets drained off and then you don't have any left with quant, okay? Cool? Practice it. Have the habit of drinking water. Work on your breathing technique. Yes. Reduce the amount of unnecessary work. Reduce unnecessary work. Yeah, doing too much of calculation, writing too much, underlining too much, putting too much strain on your eyes, all of that. And don't remember to blink. The first thing that will get tired are your eyes, because you'll be staring at a screen continuously. You reduce the amount of blinking, you'll end up getting tired easily. Got it? So work on this. This will definitely help, but this will take a lot of practice or give a lot of marks. Okay, let's go. Set 3. This one is a cutie patootie set, but you have to be comfortable with scheduling. Yeah. 6 police stations. We've given the map. What can we see weird thing about this map? This spot. This is a little weird. Yeah, because with B, what's happening? B is not connected directly to any other spot. B is not connected directly to any other spot. B is connected either to A, that's it. So anyone who comes to B has to take a U-turn and go back to A only. If there is a B somewhere in the possible routes that you're building, the next one should also be A, the previous one should also be A only. With B, that's the thing. But with everything else, with C, there are 2 routes, can go to A, can go to D. With A, there are 1, 2, 3, 4 routes. With E, there are 1, 2, 3 routes. With F, there are 2 routes. So if there is F somewhere, then you know that this is either A or E, and this person came from either A or E. So once you start thinking that, keeping that in mind, I think this should be a doable set. Okay, let's go. This one is very easy here. This one is very easy. Don't worry about it. This one will get over like that in a snap of a finger. Let's go. So the first thing we have to do is, what they're saying is the teams need 30 minutes to cross a street. 30 minutes for each street crossing. And they're doing this from where? 9 to 12. You've done this. See it once more, no, if you want. If you want to jump to the 4th set, then we'll jump to the 4th set. Whatever is your call. We'll take a majority poll. If everyone is saying 4th set, then we'll do 4th set. Otherwise, we'll do this. Put it in your chat, guys. 3 or 4. What do you want to do? If you want to jump to the 4th, we'll jump to the 4th. If you want to continue with the 3rd, we'll do the 3rd. Quickly take a call, guys. Third, fourth. No, Mauryan, 44th set is not there. Please respond only once. Otherwise, I'll do the 3rd one only. This is not vote scam. Please don't do that here, okay? I am saying 3 and 4 both will continue with this. Let's go. Okay, so I can see 9 to 12, that is 3 hours, that means 6 slots of 30 minutes each, 9 to 9:30, 9:30 to 10, 10 to 10:30, 10:30 to 11, 11 to 11:30, 11:30 to 12, okay. And they are saying what? All 4 teams start at station A at 9 o'clock and must return to station A by 12 o'clock. Perfect. So 9, 9:30, 10, 10:30, 11, 11:30, 12. Perfect. Starting point for all the teams is A. Ending points also for all the team is A. That helps us a little bit. Yeah. Anything else? Done. Clear? Now we can jump into this. They're saying none of the streets has more than one team traveling along it in any direction at any point in time. That means at a particular time, if someone is going from A to B, at the same time, no other team. So let's say team 1 is going from A to B, no other team can use this road. This road is no longer usable at that time. So let's say at 9 o'clock, if someone is going from A to B, they cannot use A to B or B to A road anymore. Okay. At that time, 9 o'clock at least. All this condition, we'll place it here and then we'll focus only on solving the table with the help of the map. Okay. Works for us? Yes. Let's go. Teams 2 and 3 are the only ones in stations E and D respectively at 10 o'clock. So at 10 o'clock, teams 2 and 3 are at E and D. Teams 2 and 3, E and D respectively, but they are the only ones. That means at 10 o'clock, team 1 cannot be at E, cannot be at D. Team 4 cannot be at E, cannot be at D. Very important to note this because then this helps us find out what possible routes we can eliminate. Okay. Teams 1 and 3 are the only ones at station E at 10:30. At 10:30, 1 and 3 are at E. This is at E. This person is also at E. The other ones are not at E because they're saying these are the only teams. So these cannot be at E. Works? Done? Perfect. 2 and 4 cannot be at E at 10:30. 1 and 4 are the only ones, B and D at 11:30. 11:30, team 1 is at B, team 4 is at E, and no other can be BE. Right? At B or at E, no other teams are allowed. Okay? Done? Team 1 and 4 are the only teams that patrol the street connecting the stations A and D. So A and E, this road can be used only by team 1 and team 4. That means team 2 cannot do this road AE. This road AE is not allowed for team 2. This road AE is not allowed for team 3 also. Only team 1 and 4 can use that road. Okay. Team 4 never passes through the stations B, D or F. So B, D, F not allowed for team 4. B is not allowed, D is not allowed, F is not allowed. That means this team 4 can either go A, E, A, C. These are the only possible routes for team 4. Got it? A, E, E, A, C, C, A like that. Done? So far good? Yeah. So we've taken down all the data. Now what did we look at? What did we see? What was the best place to begin? B. Because I know that if anyone is at B, that person has to come back to A. Yes. If this person is at B, this person has to be at A. No other way in which that person can go from B to B. A, B, A. A, B, A. Got it? Okay. This can be anywhere. Right, this can't be E or D they are saying, but these can be anything. We'll stick to this, we'll come back to this in a while. What else can we target? We can target team 4 because the number of cases are very less. B, D or F is not allowed. So if someone is at E, right, B, D, F is not allowed. Only place he can reach E is where? Through A, correct? Yeah. Now this person is at A. This person cannot come to A from B, cannot come from F, can come from either E or C only, but E is again not allowed because he is not at E. That means this has to be C. Works? Yeah. Again, at C, this person cannot use D route, so he has to use the A route only. This guy is at A. Yes. from A. Now again, I can do ACA or AEA. This could be both cases possible. This could be either C or E. We'll keep it open at this stage. Done. Team 4 is almost done. Clear, everybody? Team 4 is almost done. Yes. Can we look at team 3 now? Let's see if we can do team 3. Team 3, this guy is going from A to D. So this is done. I'll erase this off. He's going A to D through some place. Okay. So A to D direct route is not allowed. That means this person will either go ACD or AED. Only two possibilities. This guy cannot use AE route. So this guy has to go from AC to D. AC, CD is only possibility. Now look at this. 9 to 9:30 AC route is in use. This guy again cannot use AC. So this has to be E only. Team 4 is completely done. Perfect. Good to go. So let's look at team 3. Okay. So team 3 is doing what route at this moment? Is doing AC, then CD, then DE. From E, this guy cannot go to A because he cannot use the AE route. From E, there are two cases. Either go back to D or go to F. Correct? Either go back to D or go to F. So this could either be F or it could be D. Yeah. Let's see if we can check F. We'll do trial and error. Let's see if F could work for us. So from E to F, this person does. E to F. Again from F, he can either go to A, F say, so he can either go to A or come back to E. But they're saying he can't be at E. That means this has to be A. But if this is A, he can't go from A to A again. A to A is not allowed. That gives us what? That tells us that this can't be F. This has got to be D only. Yeah. Can't be F. This has got to be D only. So what he does is, he goes E to D. From D, there are only two possibilities. Either come back to E, which he is not at E. That means he's got to go to C. This is done. Team 3 is done. Cool? Good to go? A, C, D, E, D, C, A, perfect. A, C, D, E, D, C, A, perfect. Done. 2 got over. Now let's look at team 2. Yeah, can we look at team 2? So right now at 9 to 9:30 duration, from A, the possible routes are either go to B or C or F or E. Team 2 cannot use AE route. So this is gone. This is not possible. Someone else is using AC route. So this person will either go to A to B or A to F. Now I know that if anyone goes from A to B, has to return to A. But this guy is going A to some place and then to E. So B is not allowed. So the only possibility is F. Yeah. And because AF, AC, AE, all three routes are in use, this has to be AB. From AB, this person again has to come to A only. Team 1 is done. From here, I think now we can complete this bit. That's it. Clear? Yeah. Let's do this. So A, F, E. So A to F, F to E. From E can go again to F, can go to A or D. EA route is not allowed. ED route is already in use. ED route at this duration is already in use. So it can't be D either. So from E, the only place possible is F. Go to F. Yeah. Again from F he can come to A or E. From F, A is possible. Coming back to E is possible. FA route is in use nowhere, right? So this could be FA or FE. So we've done FA. From A, this person can't go to B. Can either go to C and then come back to A. Can't use AE route. So it has to be C and then to A. This has to be C because can't be C. CA route is in use. So we can go backtracking here. B to A is in use. C to A is in use. E to A is in use. That means this has to be FA. This has to be F. A to F allowed. E to F allowed. I think there will be two cases here. There will be two cases here. This can be either A or E because both are working for us. FA root is not used. FE root is not used. A to F is not used. E to F is also not used. So this is done. We are getting two cases, just two cases with just this part. Right? 10, 32, 11 for team 2. Everything else is done. Cool? A little bit of patience if you use. Yes, if you can keep in mind all the conditions, put the conditions here itself. If you are someone who does condition, take from here, read once more and then do, read once more and then do, you will waste a lot of time just shuffling between this, this and this. You have a map to look at, you have conditions to look at and the table to look at. Too much movement will confuse you. Okay? Then it's a proper scheduling based question. Just the theme of it is based on maps. That's it. Cool. So yeah, like I said, A, E, there will be two cases here. I think we can manage that. Let's go. Which among the following stations is visited the largest number of times? A should have been the answer, but A is not there. So we look at D, C, F and E. Let's look at D. D is visited once, twice, that's it. So D is visited only 2 times. Station C is visited once, twice, nowhere, thrice. C is visited thrice. So they're saying largest amount of time. This can't be my answer. Let's see if F and E have higher cases, right? I can clearly see E more number of times, but I'll confirm with F first. So F there is 1, 2, 3. F is thrice, nowhere else. This is also 3, this is also 3. Both 3 cannot be my answer. This should be my answer. E should be the maximum. Let's see. So I have 1. This could be 2, 3, 4, 5. So it's either 5 times or 6 times. This is done. Cool. So once you're done with the arrangement, I think the questions are very straightforward. Yes. How many times do the teams pass through station B in a day? How many times passing through B? Once, twice. No one else is using the AB route. AB route nowhere else is possible. 2 is the answer. Khatam. Yeah. Nowhere else do we see B. Cool. Perfect. Which team patrols the street connecting D and E at 10:15? 10:15 is here. DE. DE is here. Team 3. How many times does team 4 pass through station E in a day? Team 4 passing through E. Once, twice, 2 times. Questions are very straightforward. So once you are done forming the table, the base done, questions I think you can monetize very quickly. How many teams pass through station C in a day? Mind you, this question actually threw a lot of people off and they made a mistake there. They're not asking how many times C is being passed. They're saying how many teams. Teams, not things. Yeah, so just looking at the teams, whether a team passes through C or not. Is team 1 passing through C? No. Is team 2 passing through C? No. Is team 3 passing through C? C. I mean, Spanish C, yes. Team 4 is passing through C? Yes. So if you count C 3 times and put 3, this would be a trap. This clearly tells us that you're not being patient enough while reading the question. You're panicking, you're in a hurry, they're using your anxiety here. Okay? 3 will be a trap. They're not asking how many times, but how many teams. Only 2 teams are passing, which is team 3 and team 4. Okay? Be very careful, don't fall into these traps. So I think of all the sets that we've solved, this one was actually easier. But the only disadvantage was that the scheduling involved here, which means you have to be comfortable with scheduling to be able to do this, distribution and scheduling. Yeah. Shall we go to set 4, guys? We'll do one last set and then wrap it. Yeah, we'll skip the 5th one. Any which ways I would have skipped the 5th one. We'll do the 4th one. Let's go. So this is 2017 slot 1. Okay. This is a very beautiful set. if you are comfortable with numbers, that is, if you are comfortable with counting, basics of PNC if you know, basics of permutation and combination if you know, this one is a dead easy set, a must do set. Yeah, a must do set. You never have skipped this. If at all you are doing it as a practice or a mock and you come across this set, it's a must do one. Very little data, and the main stuff is in the data only. We'll read this. So 10 cities are there, A, B, C, D all the way till J. Okay. Flight duration between any pair of cities will be less than 1 hour. Is useless. This information is useless for us. To start operations, they have to plan a daily schedule. This is the underlying principle. This is very important. They're saying that any person staying in any of these 10 cities should be able to make a trip to any other city in the morning and should be able to return. So let's say we are talking only about 2 cities. Okay, we are talking about A and we are talking about B. Yeah, these are cities, so I'll make it a little bigger in fact. Okay. So let's say if we are talking about someone who lives in A. Someone lives in A. Okay. This person, if he goes from A to B in the morning, let's say AM. Okay. This person, if he goes from A to B in the morning, he should be able to return from B to A. This person should be able to return from B to A that very day itself by the evening. Works? Yeah. So if, let's say this is me, okay, I am going from A to B in the morning, I should be able to return from B to A in the evening. Yes. But what if my bay, okay, this is my bay, okay, yes, this is my bay, she lives at B. The same rule should apply for her also, yes or no? The same rule should apply for her also, that if she goes from B to A in the morning, she should be able to return from A to B by the same evening. Yes or no? This cracks it. That's it. That means I need 2 flights at A. One in the morning, one in the evening. A, I need 2 flights. B, I need 2 flights. One in the evening, one in the morning. Or technically, between one pair. This will apply for AC, AD, AE, AF, AG, AH, AI, AJ, all of it. Same way BC, BD, BD, so on. So one pair of cities should have minimum 4 direct flights. Yes. This will help you answer all the questions like this. You understand the basics of counting, basics of PNC, and you figure this out. All these 4 questions are in your left back pocket. Yeah. Questions might seem a little intimidating because of the size of it, but there is repeating the same thing over and over. And if you see this, let's have a look at the first question. Okay, let's go. If the underlying principle is to be satisfied, beautiful. Repeating the same thing, that we have to satisfy the principle in such a way that the journey between any 2 cities can be performed using only direct flights. Then minimum number of direct flights. Perfect. So I know that if there's one pair, I need minimum 4 direct flights. Minimum 4 direct flights I need. I just need to identify how many pairs of cities I can make out of 10 cities. So 10 cities, how many pairs can I make? 10C2 pairs. I figured that out. I cracked that. The entire set is a giveaway for me. Take it. Take and go. Take and go. 10C2 pairs, that is 10 into 9 by 2, which is 90 by 2. 45 pairs are there. So with one pair, if it's minimum 4, then with 45 pairs, there should be how many? Minimum 4 into 45, which is 90 into 2, 180 direct flights should be there. Done. Cool. Because we were able to crack this bit, answering this bit became so much more easy for us. Yeah, I didn't have to do AB, AC, AD, AE, AF, L, BC, PD, I didn't have to do that. Okay. Basics of PNC, basics of counting, khatam. Done. Yeah. Next question. So with this, they are now trying to add more stuff to it. Yeah, adding more stuff to it. They're saying suppose 3 out of the 10 cities are to be developed as hubs. Let's say the hubs are A, B and C. A, B and C are the hubs. Okay. A hub is a city which is connected with every other city by direct flights each way, both in the morning as well as in the evening. So A will be connected to all the 9 cities. A is a hub. Okay. A will be connected to all the 9 cities. A will be connected to B, A will be connected to C, and A will be connected to the remaining cities also. So it will be connected to D, E, F, G, H, I, J also. Getting this? I hope you're getting this, yeah? So it will be connected to all these 9 cities. Yes? The same thing with B, B will be connected with A, which we've already counted. For B, we've already counted this, okay? So B will be connected with A. B will also be connected with the rest of the cities. D, E, F, G, H, I, J, all the other 7 cities it will be connected. C also same way. C will be connected to A, which we've already counted. C will also be connected to B and the rest of the cities. So what are we seeing here? If we were to split it into 2 parts, make it very easy for me. If I look at hub to hub, how many pairs are there? How many pairs? AB, BC, CA, 3 pairs. If I look at hub to other cities, how many pairs can I get? I'll get 7 pairs here. 1, 2, 3, 4, 5, 6, 7 with A, 7 with B, 7 with C also. So 7 plus 7 plus 7 for A, B and C, that's 21 pairs. So on total there are 24 pairs. They are asking the same question, minimum number of direct flights, that's it. Everything else is all kachra. See, underlying principle of the airline to serve all 10 cities, already given there, repeating, that's it. So 24 pairs into 4 minimum direct flights gives us 24 into 4, which is 96 direct minimum flights. Cool? Yes? Works everybody? Yeah? Yeah, Mauryan Empire, it does not depend upon the duration, but the amount of efforts that you're putting, keep that in mind, okay? Third, suppose 10 cities are, now again they are complicating it. Earlier they brought in hubs, now they are saying, if they are divided into 4 groups. So, G1, G2, G3, G4, there are 4 groups they are saying, where G1 has 3, 2 and 2 cities. And they are saying that G1 consists of A, B and C. So, I have not been given the rest of the 7 names, but I think we can just make a guess here to be able to answer it clearly. So, let's say the other cities are D, E, F, G and H, I and J. Okay. Now the thing is, we've been given conditions where there are direct flights. Correct. This is intentionally made complicated, but if you take the setup, you can guarantee yourselves that you can get all 4 questions right. So 4 into 3, 12 marks, left, back, pocket, easy. Okay. Suppose that direct flights are allowed only between 2 cities satisfying the conditions. First condition, if both the cities are in G1, both cities in G1 means what? AB, BC, AC. This should be the link, correct? So I don't need the minimum number of flights at this stage. I just need the pairs. So for the first condition, how many pairs can I make? 3 pairs. Yes. Now look at the second condition. Between A and any city in G2. So A and G2, that means A to D, AE, AF. That's how many pairs? 3 pairs again. B and G3. So B cannot go to G2. Anyone starting at B will go to G3 only. So BG is a pair. BH is a pair. That gives me 2 pairs here. C and any city in G4. C and any city in G4 would mean again 2 pairs. One CI and CJ. Here we go again, okay? CJ, only 2 pairs. That means in total we have how many? 6 and 4, 10 pairs only. Their question is again simple, minimum number of direct flights, that's it. 40 is our answer. Yeah. These are basically 4 different PNC questions just crushed, just smashed, squeezed into one set, that's it. Yeah. Cool. Final one has just a small variation here. What they're saying is this bit is the same. This entire stuff is the same. But they are again extension within extension. This is like inception, dream within dream. They're saying, however, due to operational difficulties at A. So now there are problems at A, they are saying. It was later decided that the only flights that would operate at A would be to those to and from B. That means AC link is gone. In the first condition, AB link is there, AC link is gone. So AB link is there, BC link is there. Correct? AB link is there, BC link is there, AC link is gone. Yeah. So there are 2 pairs here. A cannot go to any other city. That means G2 is no longer a G2 at all. G2 doesn't exist only. So now G1 is ABC. G2 doesn't exist only. They are saying that G2 cities in G2 would have to be assigned to G3 or G4. It doesn't really matter where, because ultimately we are going to add them up only. So whether they go to G3 or G4 doesn't matter. If I say they go to G3, there will be 5 cities in G3, which would be what? D, E, F, 1, 2, 3, 4, 5. I and J are here only. Doesn't really matter, because any which ways we are doing single calculation only from here. So B will have, so A to G2 is 0. No longer possible. B has 5 pairs here. 4 and 5. C has the same usual 2 pairs. So now we have brought it down to how many? 7, 9 pairs. What they are saying is, then what would be the maximum reduction in the number of direct flights? We have to find out the difference. So according to question 3, we had how many? 40 pairs, 40 direct flights. According to question 4, we have 9 into 4, 36 direct flights minimum. So the difference between them is 4. This is our answer. Yeah. This is a very, very easy set, provided you can think clearly, think straight. Everything dependent upon this one thing that we found out. Yeah. 12 marks just for finding this out. Isn't that a beautiful thing? Yeah. And in the same very slot, same 2017, same slot one, this Satan of a set was also asked, set 5. The set 5, which is as kind and as generous as Satan himself. Same 2017 slot one. Very annoying. Yeah, no map given to us. We have to figure out all the possibilities. We have to look at how much time they're taking, how much time per car it is taking, number of cars. In each case, the cases are different. And to make it worse, they have two extensions also. They have two extensions also where they are building a new route now. Yes, out of the two, you can do the airlines one. This one is definitely skippable. So if it were up to me, I would have definitely skipped the set. Yes, make the rest out of the rest of the set. Works? No, Mauryan. No. Map is just the basic of it. Maps is just 4-5 lines drawn together. The key there is not the maps at all. Maps, drawing the map of that particular set is dead easy. Building upon that is very important. Identifying how much time per car, because the duration increases with respect to number of cars there. If for every additional car there is additional time taken, and you have to build up 5 cases, 40, 13, 22, 31, 04, very complicated. Yeah. Ved, no, both these sets would be the ones that you would definitely skip it. Metro line is a little simple to understand, but the complexity is in the details there, because there's so many minute stops in between, and the moment they start asking questions that are based on optimization, it becomes very, very annoying. Same applies for the visa one also. Yeah. Cool. Perfect. The ones who joined late, guys, you can watch this entire video, right? Initially, Rahul sir would have done some crazy good questions with quant, and towards the end, there are 4 sets that we have done, all based on maps and network. Yeah. Perfect. 2.5 sets is good enough, Sia. I don't think you should even aim at more than that. 2.5 is really good. Cheers, everybody. Done. Alright, thank you so much. I will see you soon. Thursday we are doing a pure DI. So join this Telegram group. I'll share the link also. Thursday, which is 20th of November, we are doing DI one-shot marathon. Yes, don't forget to join this. It's on the main channel, MBA Wallah channel. But if you join this Telegram group, I'll share the link with you. Yes, I think we'll start somewhere in the afternoon around 12 or 2 p.m. I'll let you know. 12 p.m. is a little tricky because lunchtime and all that. So we'll figure that out in a while. Okay, done? Works, everybody? All right. Thank you so much, guys. Yes, Priyanshu. It's been ages. Yeah. Then I know a lot of you have asked for this. Sir, DI one shot, please. All DI, all possible kind of charts, crazy level sets, all of it I'm bringing. 20th of November. Put that on your calendar, okay? Cool. Done. Next. Alright, so I will see you all on Thursday then. I think the next time we will see each other would be on Thursday. All the very best, folks. Cheers. See you all.